Yo, what's poppin', man? In this video, you and me will build a complete e-commerce filtering solution from scratch together. Once a user visits your website, you're gonna see beautiful loading states for all the products. And here's the main thing on the left side, the product filtering functionality, the main thing we're gonna build in this app. Because these product filters are some of the ones that the e-commerce product giant Etsy uses, and we are gonna implement them together. You can filter products by color, by size, and here comes the best part, even by price in certain ranges, including a completely custom range that you can set via a slider. Now, in this entire project, I want to teach you two extremely important tools you're gonna see in open source projects. You're gonna see these tools in enterprise projects. They're incredibly popular, and the reason is they're damn useful. And for once, that's React Query. In its most basic form, React Query allows you to send data from the front end to the back end and back, right? That's what it does. But things like loading states, arrow states, caching, and so on is all done for you with React Query. Super important tool. That's number one you're gonna learn. Number two is Zod, a schema validation library. And this sounds kind of woo-woo. Like, what the hell is a schema validation library? So here's the idea. You define the shape of what a product looks like. You can think of this. For example, you say that, hey, each product we offer in our store will have a size, will have a price, and so on. After defining this shape once, and that's the beauty of the tool you're gonna learn in this video, you not only get full security on the back end, that all requests made to your backend contain exactly that data that you're expecting, so this is awesome for security, but also you get full type safety in the front and back end. So yeah, this entire app is gonna be written in TypeScript, and we're gonna get full type safety for anything that we work in. Along the way, in this app, I wanna show you some very common useful web development conventions, such as how do you define constants. I learned this at my very first dev job, and it's been super useful ever since. I want to teach it to you because chances are, if you ever work in something like an enterprise project, you're gonna see stuff like this. You're gonna learn how to debounce inputs. What does that mean? Basically, it's amazing for performance. Check this out. As we move the slider, each time the thumb is moved, a request actually fires to our API. That's not good for performance, right? With debouncing, what you're gonna learn in this video, only after a certain time that you define has passed will one request actually be fired to our backend, which is great for performance and just not kind of cooking your API, right? And all of this you're gonna learn in a super accessible and well-designed app. And by the way, as a bonus, all the products that you see in the demo I have prepared for you, all the assets are made available to you, and we're gonna use a seeding script together. What that means is we're gonna put all the products you can see in the demo right here into your own database, so you can visually have something to work with, the exact same data that I'm using in this demo right now. So all you need to do is run the script, and it's in your database, and you can also work with it and show it off on your portfolio, for example, if you want to, so it actually looks good. Now, following along is 100% free. No credit card, no money for any tools in this video, completely free from start to finish. We're gonna do everything I just showed you in this single video. In under 3 hours, we're gonna learn all of this, and also we're gonna go through all concepts in detail. So why are we doing what we're doing? So you understand the idea behind the code and can use it for all future projects and not just this one. So you're gonna be the super future-proof developer that has the concepts in their head and actually understands what they're doing. So enough talk. I hope you are as hyped for this project as I am. This video was a ton of work, and I'm super excited to share it with you right now. So whip up your code editor, get started, boot up your PC, whatever you need to do, and let's get started in building this thing from scratch right now together. So how are we going to go about this? So the first step will be the UI design. This kind of builds the entire foundation for everything that's to come later. And then we will actually go ahead and add the functionality. So that's going to be the entire filters for the color, for the size, for the price, and so on. But of course, we need something to build on top of that first. So first step will be making things look good, and second step will be making things working. And this is going to be the most interesting step because this involves like the entire thing that I just teased in the intro, like React Query, like Zod, for example, schema validation, some common patterns you will see in web development, and so on and so on. That's going to be in this functionality part. But of course, this is also super important, the UI design, making things look good, right? So let's get started in doing this. And we will start in our command prompt. And this depends on where you want the project to live, right? I'm going to put this on my desktop, but you can put this wherever you want. And then we will type in pnpm dlx or anything else. Like you could also use npx for this. This is the node package manager. You could also use yarn to create this project. This really doesn't matter, but I want my dependencies to be installed with pnpm out of the box, which is a package manager similar to npx. So we're going to use pnpm dlx create next app at latest, and then give it any name that we want. For example, product filters. I'm gonna call this and then hit enter. Now, if you were to use npx, then the command would look like this. And I'm gonna use pnpm dlx to do this and hit enter, but it really doesn't matter what you use because the questions it will ask you in the next step are always gonna be the same. Would you like to use TypeScript? Oh, hell yes, we do. Would you like to use ESLint? Yes. Tailwind? Yes. Source directory? I prefer this, but this is personal preference. As I said, I like it though, so we're gonna choose yes as well. Yes for the app router, and no, we don't want to customize the default import alias. Now that's gonna install all the dependencies. Let's give this a bit less space. And with pnpm, this is gonna be really fast. With npx, this is gonna take a bit longer because pnpm has some really nice built-in caching implemented in it. But once that's done, implementing or downloading and installing all the dependencies, and there we go, it's finally done. So we can get started with our first step, the UI design. So a little pro tip, by the way, if you want to open a folder in VS Code, we can simply cd into the product filters we have just created, hit enter, and then type in code dot. That's going to open the current working directory we're in up in VS Code. It's going to do it here on my second monitor, and there we are in a new Next.js project that we created with pnpm. That's why we have a pnpm log. If you did it with npx, then you would have a package log, or with yarn, you would have a yarn log right here. So perfect, very, very nice. So let's see if everything is working. Before we start anything, let's see if the default setup is working. And I just noticed I already have another app running, so I just went ahead and stopped that real quick. Let's start this up again, and that will start our project up under the 3000 port under localhost. So let's navigate there, and we should see the basic blank Next.js page. And if we do, then that means that yes, we have set up the project correctly and we can actually get started. Perfect, there we are, which means we've done the setup correctly. Everything is working as expected. Very, very nice. And we're gonna start this entire thing right here in the page.tsx that was generated for us by Next.js. So what we're gonna do is remove everything that's already in here. So we're gonna mark the entire main section right here. And I have a little hotkey for this, by the way. I can just use Control M. And if you're wondering how to do that yourself, you can go to File, then Preferences under Keyboard Shortcuts. And this is called Emit Out. Yeah, this one, Emit Balance Outward. And I set this Control M. So if you want to do the same thing, just set this key binding. And that allows you, quick pro tip on the side, by the way, to go into any HTML or XML element, hit that shortcut, and then the entire element will already be selected for you, which is super handy and will just allow you to code a bit faster. But that's only a side note, right? So this right here is where we're gonna start. And we're gonna start with a main section. And this main section, we can give it a class name because we already installed this with Tailwind. And this is gonna be an MX of auto, a maximum width of 7XL, a padding X of 4, on small devices, a padding X of 6, and on large devices, a padding X of 8. And by the way, if you've got the Tailwind extension installed, and that will be this one right here, Tailwind CSS IntelliSense, that will allow you to hover over these class names and see which CSS is actually applied under the hood. So what does max with 7XL mean? Well, basically it's just 1280 pixels. That's all it means. So it's a really handy extension we're gonna make use of here. And by the way, just to make our life easier, let's also open the project up side by side so we can see in real time what we're even doing here. So I'm gonna say hello world right here, and let's see if that appears, and it does. Perfect. So we're all set up to go. And now, of course, you don't need to kind of follow along with the hello world here. That was just an example, and we're actually gonna get started with a div element in here. So this div is gonna get a class name of flex, an items-baseline, a justify-between. We're gonna give it a border-b for bottom, so only on the bottom will it have a border gray of 200, and then a padding bottom of 6 and a padding top of 24. Now, inside of this div, we're gonna put an h1 element, a heading 1, large one, and this is gonna get a class name of text4xl, a font of bold, a tracking dash tight. And if you're wondering what that means, it's basically a letter spacing. So the letters in the headline will be moved a bit closer together. It looks really nice in headlines, by the way. And a text gray of 900. Now, what is this H1 gonna say? This is gonna say high quality cotton selection. And let's hit save. Now, you might notice that, hey Josh, this actually looks pretty weird. Like the background is black, the text is like this dark kind of grayish color. How do we fix that? This doesn't look good. And you know what? You're damn right. This actually doesn't look good. So what we're gonna do is get set up with a UI library that gives us some really nice default CSS variables out of the box that are gonna make our page look very nice. The way we do that is by saying npx shadcn-ui at latest init. And that's the initialization command for a certain UI library called ui.shadcn.com. I use this on nearly all my projects right now. And one of the main reasons is not only is it a component library that gives us access to a bunch of really nice looking accessible components out of the box, but we also get the entire color schemes with it. And these look great out of the box with almost no configuration, which is why I really like this UI library. So to get started, we're gonna select the default style. We're gonna go with zinc as the base color, but this really is personal preference. This is like, the slate is kind of like a bluish gray, I guess. The zinc is just basic gray, and there's some other tones you can choose from here. So I prefer the zinc. Would you like to use CSS variables for colors? Yes. We definitely want that, because that's actually going to make changes to the globals.css right here that Next.js gives us out of the box and sets these variables right here for both the light mode and also for the dark mode. So whichever you want to implement, you can do both if you want to, but the defaults it gives us will look very, very nice out of the box. So once we start back up our development server using yarn dev or npm run dev or pnpm run dev, and refresh our page, we should be able to see that things changed visually. And there we go. I mean, dude, how easy was that, and how much nicer does this look compared to before? Like the difference is just crazy. Let's be real here, okay? And all that just by running one CLI command for the UI library. Hell yeah. All right. Okay, so perfect. We can now continue under the H1 knowing that our app will actually look good now. Okay, because again, I don't want to teach you just like the functionality, but of course you also want to have something to show for it, you know, that you can show to people. Okay, so the div we are going to create under the H1 element is going to get a class name of flex and items-center. Now, inside of this div, these are going to be, and you don't need to follow along with this, I'm just going to type this here to show you. These are going to be the sorting options that are going to be on the right side right here, later above our product view. And to make this happen, if you paid attention to the demo, this was like a kind of drop down menu. And we're not going to implement that from scratch either. There's a super neat thing we can do in our command line. And let's clear this for a second. That is npx shadcn-ui at latest or UI library add, and then it's drop down dash menu. And hit enter. By the way, all components you can already preview while this downloads right here. So this is going to be the drop-down menu on ui.shadcn.com. You could use any other UI library if you wanted to. I just like this one. It's just personal preference. And basically, this is what the drop-down menu is going to look like. And that's fully accessible. So what that means accessible is when we, for example, press escape, then the menu will close, or when we click away, and that we can also use arrow keys to kind of select stuff, right arrow key, left arrow key right here. How cool is that, right? And that's all done for us out of the box, but we have full control over the styling, right? So let's start back up our development server once we install this drop-down menu. And what that does is basically it creates the component in our own project. So there's no abstraction. We can see exactly the entire component it basically installed for us right here under the UI folder in our components folder, right? So it basically created this dropdown menu.tsx file. What that allows us to do is beautiful, because we can now use this, it's called dropdown menu, from our own source code, right? There's no abstraction. So we're gonna create the dropdown menu right here. And then to create an item in the drop-down menu, we need basically two things. There's going to be the trigger of the drop-down menu, which is the button that opens it. And then there's the content of the drop-down menu, which is super intuitive. And that's why I really like this API design. Check this out. we can create the drop-down menu trigger also from our own components and not from Radix UI, which it uses under the hood, but we want the styled version of it. So this needs to come from our own drop-down menu in our code, not from Radix. Now, inside of here, we can say, for example, sort and give this trigger a class name, because this is nothing else than like a button or div element. We can actually see what is it. So this is a React HTML button element, right? So under the hood, this is just a button that is wrapped for us in this kind of little abstract way to give us a nicer API to interact with. And this is gonna get a class name of group, an inline dash flex, a justify dash center, a text of SM for small, a font dash medium, a text gray of 700, and on hover, we're gonna give it a text gray of 900, just to have a little mouse cursor interaction once we hover over it. So let's move this into a side-by-side once again. And if our dev server is running, we should be able to see those changes show up right here where it says options. So let's let this reload, and we should be able to see the trigger, which is nothing else than a button element. Now, when we click it, nothing happens yet, but it does have the correct kind of cursor and everything, so we know we set this up correctly. Now, right below the sort, we're gonna put a little icon. And this icon is gonna come from an icon library that is called Lucid React. Now, low-key, I use this in every project that I do. This is a super nice, completely free kind of icon library that gives us access to all the SVGs. And let me show you what this does. Let's give this a bit more space. We can go over to icons, and you can see all the icons that are in this library. It's super cool. There's a bunch of them, like 1.5K almost, which is pretty nuts if you ask me. And we can simply install this and use all the icons as is. It's honestly super cool. So the way we're gonna install this is by saying pnpm install lucid-react and hit enter. That's gonna install the icon library package into our own app, so we can simply start back up our development server and then use the icons right here in our app. Now, the icon we want to use right below the sort text right here is the chevron down icon from Lucid React. And this is gonna get a class name of -mr-1. So we give it a negative right margin. That's all this does. A margin left of 1, a height of 5, a width of 5, a flex shrink of 0. There we go. A text gray 400, and we're also gonna give it a group dash hover, and I'm gonna get to what this does in a second here, of text gray 500, so a bit darker. Now, what is this group hover? All this means is because we declare the group up here, when you hover over the trigger, then also the same effect will apply to the chevron down. Now, let me just show you what this does. So you're gonna see the icon show up right here next to our sort text once this loads, and sometimes Next.js takes really long to load, but also my PC is pretty old. It's like 7.5 years old. So sometimes it takes a bit, but anyways, once we see the icon right here, you can see when we hover the sort text, even though we're not hovering the icon itself, it will still get a bit darker. And that's what this kind of group does right here. And the group hover, it's pretty useful. So right below the drop-down menu trigger, this is where we're going to continue with the drop-down menu content. And you see how cool the API design is, like how intuitive. We have the menu, we have the trigger, which is the button, and we have the content. Like, I really like this API design. Now, the align property, align of the drop-down menu content, we're going to set to end. And you're going to see what that does in a second. It determines the position of, and why is this not a side-by-side anymore? There we go. It determines the position of where the drop-down menu will open. And inside of this drop-down menu content, we want to display all the sorting options there are. And now comes one of the parts I mentioned in the intro. So how do we define the sorting options like in a really clean, kind of understandable, readable manner? And what I'm about to show you is a convention that is super common in in basically everywhere. Personal projects, enterprise. I've seen it everywhere, but especially important in enterprise. It's that at the top of the file, we can declare constants, and we're going to put them in all uppercase. Now, the uppercase indicates that this is a constant value. It's a magic thing that we define somewhere that is never changing. And it is a really useful convention to put that in all uppercase. So when you see it later on in the code, you always know this is a constant. and this never changes. Again, this will get very clear as we kind of go through this together, and you'll understand exactly why we do this convention. So each sorting options that we define right here will get two things. It will get a name, and this is what's going to show up actually in the drop-down menu. So for example, none, and it will also get a value, and the value for the none will also be none right here. Now the next array element is going to get, of course, the same properties, a name and a value. The name is going to be price and then low to high. And the value of the sorting option will be price dash ASC. So ascending, we go from low price to high price. And this is later how we will determine the actual data fetching logic from our database. So the value is useful for us in code, and this is what's shown to the user. Now, last thing, and by the way, pro tip, if you go into a line in VS Code and hold Shift, Alt, and arrow down, you can simply copy the line down. Now, we only need it once, but you get the idea. And we're going to change this the other way around. This is going to go from high to low, and then the value will be, of course, you can probably guess, not ascending, but descending from high to low prices. That are already all the sorting options we need. And we're going to add one more thing to this, and that is the asConst right here. Now, you might be wondering, what does the asConst do? And by the way, this is one of the most powerful features of TypeScript. So imagine this, we don't have the asConst right now, and we hover over these sort options, and we see it's a name and value string array. If we add the asConst now, the thing that appears when we hover over this fundamentally changes, because TypeScript now knows this is always an array that is exactly 3 elements long, these right here, and it has exactly the string values that we can see right here. These never ever change. We cannot push anymore. So if we try to push into the sort options, which is an array, so we have the push option, we can see this won't work because property push does not exist on type read-only array, right? So basically, if we didn't have the asConst, yes, we could push into it. With the asConst, we're telling TypeScript that this will never ever change in length or value. And this is really useful for type inference, as you're going to see in a second here. So now for the drop-down menu content, let's finally finish that. When we click on the sort, we want a drop-down menu to open with the content of the sort options. How do we do that? Well, we can simply map over all the sort options, and for each option that we get from that, we can render out some JSX. Now, the JSX that we're going to render out is going to be a button, and because we're mapping over something, this first JSX element always needs a key, and this is going to be the option.name. So this is a unique key for every button that we're mapping over. Basic React right here, you probably already know that. And this is going to get an on-click handler. Now, what do we want to happen when the user clicks a sorting option? Understanding this is the most fundamental concept in the entire app that we're building right here. So we're going to have a bunch of filters, like the sort, for example, the size, we're going to have the color, and so on. And imagine this down here is the actual UI that the user can see and interact with. UI. And basically, when the user changes any filter that is visible to them in the UI, then we want to keep track of those changes in state that we can later then send to the server. And this looks kind of bad. There we go. So when the sorting changes, for example, in the UI, we want to make sure that we keep track of all those changes. And of course, similarly for the size, and also same thing for the color. If anything changes down here, we want to make sure we keep track of that so we can then later send it to our database. The question now is, well, how do we keep track of that in state in a really readable, nice kind of way? And that is a fantastic question. So what data do we have to work with here? Well, basically we have the option.value, which is the actual sorting kind of, I guess, algorithm you could call it, that we want to use for our products, right? This is what matters to us in this on-click handler, the option.value. Now we need to store this value in state to keep track of it, to send it to the database. How do we do that? Well, by declaring state right up here in our component. So let's call this the filter and the set filter, of course, by convention. And this is going to be equal to use state in its most simple form. Right? And because we're using Next.js 14, this is by default a server component. It's rendered on the server. But if we want any kind of interactivity like this React hook, then we need to mark this component as a use client component right here in very, very top of our file, even above the imports. That's how we are able to use the React hooks right here. Now, how do we make the state super readable, super easy to understand when anyone looks in our code, when we need to maintain our code? This is the approach that I came up with, and I really like this one. So in its most simple form, we want to keep track of a property, and that is called the sort. Now, in state, we always need to give default values for anything. So by default, the sort is going to be none, this right here. And then we can change it to price ascending, price descending, or we can change it back to none if we want through the drop-down menu. Now, what this allows us to do is when a UI change is made right here in the sorting, then we can now put that in this filter by using the set filter function. Now, enough theory, how do we do this in practice? How do we now use this? Well, basically, in the onClick handler, we can simply invoke a function, and that is syntactically not correct. There we go. And whenever you click the button for the corresponding sort option, we want to save that in state. So we can set the filter state to whatever it was previously, which we receive as the first argument, and then directly return an object. And this object will contain everything that was previously in the state, which later will be all the other filter options like the size and the color. Right now we don't have any, but this will be important later. And then of course also the sort. And the sort now is going to be the option.value. So semantically all this means, right, is keep all other options that were already set, like the size and the color, and only change the sorting to whatever the user just selected, which is the option.value. All right, and then inside of the button, we can simply state the option.name. Now, I know this was somewhat abstract, but we can simply log out the filter right here, console log filter, and I will show you exactly what this does. So let's open up the console and let's refresh the page. Now we should be able to see that when we click this, okay, this doesn't look good yet. We will get there, trust me. But when we click, for example, price low to high, we can see this is now successfully saved in our state as price ascending, price descending. And when I now click none, then we will see the sort is set to none. And all the other filter state is kept as it is because we spread it in right here. Now, of course, this doesn't look super good yet, so let's fix that. Let's make this drop-down menu actually look kind of not like dog water, right? So we will pass this a dynamic class name using our CN helper function. What is the CN helper function? If you're not familiar with it, this is a utility class name merging function that our UI library actually installed for us during the initialization step. What this allows us to do is to pass a default class name right here inside of this function. So this is going to be a text left, a width of full, a block, a padding x of 4, a padding y of 2, and a text of small. And this class name will be applied unconditionally. So always this will be applied. And then we can combine this with optional class names that will be applied conditionally. For example, we want to apply a text gray 900, but only under the condition that the option.value, so what is rendered out here, is equal to the filter.sort, so what is currently selected as the sorting filter. And by the way, we can also apply a bg gray of 100 in that case. And then the second conditional class name we're going to apply is going to be a text gray of 500 when the exact opposite is true. So when the option.value is not equal to the filter.sort, so for any other option. Once we save that, you can see exactly what this does. First off, this now looks a lot better. And secondly, the active thing is currently now selected, kind of highlighted in the text, and it just looks a lot nicer because it's very clear to the user which option is currently selected and which ones aren't. Beautiful. That is our sorting, and we're already saving this in state, which is a perfect prerequisite to later send it to our API to actually get the product results. Now, let's add a button. So right below the drop-down menu, and this button is gonna get a class name of -m-2, a margin left of 4, a padding of 2, a text gray of 400. On hover, this is gonna get a text gray of 500. On small devices, we're going to give it an ML of 6, a margin left of 6. And on large devices, this is going to be hidden. So this is going to be the mobile filter button. And inside of here, we're going to use the filter icon from Lucid React. This is going to look really nice. And this is going to get a class name of height 5 and a width of 5. And that's it. So basically what this does is it only appears on very small devices, and it's going to be the little filter icon that when we click it, you can implement like a mobile drop-down menu, whatever you want, if you wanted to show the same filters that we're building in this video on mobile as well. Now, one thing I want to do right now with you is implement the data fetching. So we can implement all the filters that we want, but if we don't have products to see this entire thing and demonstrate it literally visually, then I don't think this makes too much sense. So what's way more fun is first adding the products in and then actually working on the filters so we can see what we're doing in real time. And to do that, we are gonna create one new folder, and this is gonna be our database folder. So this is where all the database related stuff is gonna live. This is gonna be in our source directory. Let's create a new folder, and let's call this DB for database. And let's create a new file in here, and this is gonna be the index.ts, from which we are going to create our database. So we have access to the database throughout our application. Now, your choice of database, of course, really depends on what is the app that we're trying to build. In our example, we're going to use the Upstash vector database. Full disclosure, of course, I work at Upstash, right? So it just makes a lot of sense for me to use this. It takes like 1 minute to get set up, so we can actually focus on the important stuff, which is the filtering. However, of course, if you want to use Postgres instead or MySQL and so on, be my guest. No problem at all. You can totally follow along with these as well. I think just Upstash vector is the easiest way to follow along with this. And of course, it's also totally free. Now, once we navigated over to Upstash for this, let's go to the vector tab and let's click create new index. And let's call this index. What do we want to call it? Let's call it product filter as well. The region is going to be Ireland for me, so in the EU, and the dimensions of the vector are going to be 3. Later on, this is going to be the product color, the product size, and the product price. So 3 dimensions make sense here. And as the distance metric, we're going to use the Euclidean, right? So very, very brief explanation. Euclidean versus what is the alternative? The cosine right here. What's the difference? Basically, Euclidean distance measures the actual distance between 2 vectors, right? So the Euclidean distance measures this distance right here versus the cosine distance measures the distance or the difference in the angle between 2 vectors. So it measures the alpha right here. That's cosine. This is Euclidean, and Euclidean is especially useful in smaller dimensional vector spaces, which we have with 3 vectors, right? So we're gonna use Euclidean distance in 3 dimensions and hit next. Pay as you go is fine for me, but of course you can use the free plan, but they already have my credit card data, so I'm gonna use pay as you go. And then all we need to connect to our database is under the details right here. It's gonna give us the .env stuff that we need to connect to our database. So we can simply copy this over, go into our project, into a .env file where secure environment variables live, paste this in, install one dependency, which is the pnpm install at Upstash, /vector. Let's give this a bit more space so you can see easier what I'm doing here. pnpm install at Upstash/vector. Hit enter, and that's literally all we need to do to connect to our database. So we can simply go into a index file for the database that we created, and then just already establish the connection to our database, which is as easy as exporting a const db, and this is going to be equal to a new index we now get from the Upstash vector package. We can simply invoke this, and this is literally all we need to connect to our database. That's why I said following along with Upstash is by far the easiest one. Again, full disclosure, of course, I work there. You can follow along with anything else if you want, but this is just incredibly easy to actually focus on the product filtering, because that's literally all we need. And it's automatically going to pull the values from our .env file and use them to connect to our database. Now, into this index, we can actually pass a TypeScript generic, and this is going to be really useful because let's take a look at what this looks like. We can define a type product. Now, what is this for? Passing the generic into our database connection right here. So imagine each product has an ID, which is going to be a string. It has an image ID, which is going to be a string as well. And by the way, I recommend you to follow along. This is going to be important for later. This product, or each product rather, has a name that's going to be a string as well. Each product will have a size, and the sizes are going to be either an S or an M or an L. Each product will also have a color, And the colors are gonna be either white, or they can be beige, or they can be blue, or a product can be green, and lastly, a product can also be purple. Purple. And these are some colors that I just prepared for this video. Of course, you can have more colors, less colors, if you wanted to. And each product will, of course, also have a price, and this is gonna be a number. Now, what's the benefit of passing the generic into our database connection right here? Basically, imagine this. We query data from our database. By the way, you don't need to follow along right now. I'm just showing this to you. We await a database.query and query some vectors, right? So for example, we could use some information here to query. We're going to get to that later. It's not important right now. What is important is that all the vectors that we get back in the response, so for each vector will also contain the metadata that is associated with that vector. And if you notice, if we hover over this, the metadata is now actually typed. It's type safe. So if we were to access a property on here, we can see it has the color ID, image ID, and so on and so on. So all the properties that a product has that we passed as a generic here. If we didn't pass that generic, there would be no type safety. That's why we pass it right here. It's super, super useful for later, so we can work in a completely type safe end-to-end kind of way. Now, how do we get demo products into our database? And the answer is actually pretty simple, by doing a seeding script, seed.ts. That's what I mentioned in the beginning, which I already completely prepared for you. Now, at the time I'm recording this video, there is no GitHub link I can give you for this project. Of course, there will be when you're watching this video right now. It will be first thing in the description. However, while I'm doing this, I just have this open in a secondary project, and we can navigate into the public folder, copy all images that are here, and then copy them over into our local public folder. By the way, we won't need the SVGs right here. Let's get rid of them. So go into the GitHub link that's in the description for this project and simply copy over the images. These are all the images we need for all the demo products that are going to be in our database. I prepared every single one of here in Photoshop in the different colors and so on, just so you have a really nice looking project. So we can see very visually what our filters do here on the right hand side. And also, I prepared the entire seeding script. So you can find that under source db and then seed.ts in the GitHub repository. And you can simply grab the entire seeding script. This is not important to understand, right? So I want to teach you how to write good quality software in this video. The seeding script is not very important for that. So it's totally fine to just go ahead and copy and paste that into the seed.ts we have just created. Now we're gonna get one or two errors here in our seeding script, and that's totally fine. We're gonna fix them right now together. So import type product, it doesn't know where the product type is coming from. That's understandable, right? Because we're not exporting it, so we need to export the type from our database. And it also doesn't know where these colors and sizes come from. So that's because I did it a bit different in the original project, but I don't really like that approach anymore. So I think a better approach to solve this problem is to declare a const, and this will be in uppercase colors right here. And this is going to be equal to all the colors we have just defined in our database file. So we can simply grab all the colors right here, copy and paste them right here. Of course, that's gonna give us a syntax error because this is TypeScript syntax and not JavaScript. So we need to wrap this in an array and replace all the pipe operators with a comma. And we can also mark this as const if we wanted to, just to tell TypeScript that, hey, again, this array will never change in length or in content. And the same thing we can do for the sizes. So the sizes right here are going to be also in array, and same thing right here. We can grab the sizes from our index.ts, paste them right here, and replace the pipe operators with a comma. And if you wanted to, again, this is just personal preference, also mark this as const, because this will never change. Last thing that's giving us an error right here is that we don't have the .env package. Super simple fix, npm install .env -d for a development dependency. We don't need it in production. This is just for our local development. So this seeding file, which is separate from the rest of our application, can actually read from our .env. So it can connect to our database and push all the products inside of our database. So what is it actually pushing into our database? Each product with an ID, the actual vector, which contains the product color, the product size, and the product price. And also as the metadata, we are attaching all the properties that a product has, like the ID, the image ID, color, name, size, and the price. Now the details here are not too important to understand. If you want, you can kind of pause the video right here and get a more detailed overview. But the important thing is that it just pushes products into our database that we can work with in what's important in this video, which is the filtering functionality, right? And all we need to do for that to happen, to get the products in our database, is to define a seeding script in our package.json. Now this seeding script is gonna be yarn tsx, or you could use any other manager as well. I just normally use yarn for this, ./source/db/seed.ts. So basically we're using a tsx package to execute the file we have just defined, the seeding script. And this tsx package is a super simple package that we can install. npm install tsx-d, once again as a development dependency that allows us to super easily run TypeScript files that are separate from our app. And normally with like ES build and everything, this would be a bit harder, but TSX makes that super easy. So all we can do now to push the products into our database is to run the seeding script right here we have just defined. And if we want, we can also go into the data browser in our database and take a look at that in real time. So once we execute the seeding script, oh, we get an error. Of course we do, right? Let's see what the problem is. Upstash vector rest token is missing. Okay, and that's probably, did I forget? Yes, so what we forgot to do is also to use .env right here in our database file. So right now, because this seeding script is separate from our application and it imports our database, the database will also be run in a context that is separate from our Next.js application. In Next.js, you can by default read from the .env. In a separate file, you cannot. The fix is extremely easy. We can simply import everything from or as .env and then from .env, just like this, and simply call the .env.config right here. And this allows this file, even if it's separately called from our Next.js application, to read from our env file. Let's clear the terminal, CLS, and run the seeding script again. And hopefully this time right there, done in 1 second, we can see in our database, if we go ahead and refresh this, that the vectors are here. So there's a lot of products, 20 to be specific, that have been added to our database, and they allow us now to really visually apply all the filters in our application. We can see all the product data is here, like the ID, the image ID. This is absolutely perfect. The name, the size, very, very nice. And what that allows us to do now is to actually fetch the data from our API in our own application and display the products right here on the page before we get into the other filters. It's just going to be nicer for us to work in. So how do we get the products to show up on our page? And the answer is, well, by fetching them from our API route. Now that's easier said than done, right? Not really, because there's one really cool package that is called React Query, what I also mentioned in the very beginning of the video. React Query is a super common and super good, both of them, utility for data fetching. Right? Of course, you know, you could use like the regular fetch API to fetch data from /API/products or however you design your API. Yes, you could do that. But what about loading states? What about error states? What about caching, synchronizing server state, and so on? Well, that's exactly what TanStack Query solves. It's very, very common. You're going to see it in a lot of places. The company I work at, we also use it to fetch data in our console, especially in enterprise and personal projects everywhere, basically. It's a very, very common thing. And the package is called tanstack/react-query. If we type that in, you can see that right here. Published by Tanner Linsley 1 hour ago. Well, that's pretty recent. And how many? Yeah, it's got over 3 million weekly downloads. As I said, it's super common. People like it a lot, and for very, very good reason. Also, the setup is super intuitive. So we're gonna say npm install tanstack/react-query and hit enter. Now, how do we set this up? How do we fetch data from our server? I don't think this is gonna take longer than 5 minutes, and you're gonna see why. First thing we want to do is create a new file in our components folder and call it the providers.tsx. Now, first thing we want to do in this providers file that we just created is marking it as a client component by saying use client. and then declare this as a normal React component, right? So the const providers is going to be equal to an arrow function that we export default at the bottom. Providers, there we go. Now, inside of these providers, we are simply going to return the query client provider. And this should be auto imported from TanStack React Query that we just installed. It doesn't. So if that ever happens to you, simply hit Shift Control and P and hit developer reload window. That's gonna restart VS Code while keeping all the terminals running and so on if you had that running. And then most likely the auto imports, wow, huzzah, they suddenly work. So the providers, all they do is they contain some React children and they provide context to the rest of our application. To receive the children, we can use them as a property, as a prop, right here, receiving them in the component. And this is going to be of type props with children, a utility type we get from React. And because the children are the only thing that we want in this component, we can simply pass it an empty object generic right here. And that's just going to type the children for us. Of course, we could also do that ourselves, but this is just a really nice pro tip. And then inside of the query client provider, we can put our children, which now means that all the children further down in the DOM in our React application will be provided with React Query, because this is what we need to do to make React Query work. And this also takes a client, right? The query client provider also takes a client. And this client we will create above the component to make it cached. And this is going to be, the const client is going to be equal to a new query client, right? If you don't really understand what's going on, this is not a problem. This is something you do once in the application, and then it basically just makes you able to use React Query, right? It's not too important. Basically, the query client is a cache that we can use to keep track of the data that we get back from our API route. It's very useful. And the last thing we need to do is go into our layout.tsx and now wrap our entire app with these providers, providers right here, and then provide the children that we get in our layout, which is, by the way, created automatically the layout by Next.js for us. Simply wrap the children in these providers, and that's literally all we need to do. That's the React Query setup. We can now get started in using it, which is the much more kind of fun, much more important part, right? So how do we use it? In our page.tsx, we can simply get started in fetching data from our API by using the use query hook we get from TanStack React Query. This is for GET requests to our API endpoint. If you wanted to do alternative requests, you could use the use mutation. If you wanted to change data, the use query is for reading data. Now, inside of here, we can pass an object and pass this a query key. And the query key is an array of, and we can pass a string in here, the products. So this is what the result of this data fetching will be cached as. And if, for example, we had a kind of constant in here like our filter, if the filter changes, then this query would automatically be invalidated from the cache. So this is for the caching mechanism. It's super, super cool. It can get much more advanced, but I don't think that's really useful to get into right now. This is the most simple way to go about things, and this is perfect for what we are trying to do. And then in the query function, we can pass this the actual function that will define how we fetch our data. So in this function, you normally always call your backend or any other service that you want to fetch data from. In our case, that's going to be our local backend. And we could do this using the normal fetch kind of API. I prefer just syntactically to use Axios for this. Axios is an HTTP handler or HTTP client that we can use. I think it is like super, super popular. Let's see, yeah, over 50 million downloads. It's kind of nice. It's just some syntactical sugar. You can totally do this with the regular fetch API, but I prefer to do this with the Axios package. So pnpm install Axios. And I know, like, we are installing a lot of packages, right? And that's true, but it is also very common to have a lot of packages in your actual like production settings. So it's not unusual to use a lot of packages for stuff like this. So what Axios allows us to do is to make the syntax for fetching data really, really intuitive. So we can say const and then worry about the destructuring later here is going to be equal to Axios, and we need to await this because this is going to be an asynchronous call to our backend dot post. And by the way, we also need to import Axios at the very top. import Axios from Axios. So we have access to the package right here where we need it. And the cool thing about Axios is that it makes TypeScript or type safety super easy by passing in a generic right here before we actually invoke the function. Now, what can we pass in here? Basically the result of what our API will give back to us. And what we will send back from the API is going to be a query result, which comes from Upstash vector. And this also takes a generic in which we can pass the type of the metadata of each product that we get back, which is nothing else than our product type that we defined in our database file, right? And we also are expecting an array of this. Now for the actual function that we will invoke to fetch the data, right? First off, what is the endpoint that we're calling? And this is going to be HTTP and then / localhost 3000 /API /products. And of course, if you deploy this to production, then you could also use the production URL right here. And then for the data that we will be transmitting to that endpoint, these are going to be our filters. So as the filter that we're going to send along for each request we make to get the data, we can send along right now the only filter that we have, which is the sorting filter. And this is nothing else than the filter.sort. As easy as that. That's why I like this API design so much. It makes the request look super, super readable. And you're going to notice the same thing later. Once we add the color and price and so on, it will remain as readable as it is right now. So what we can destructure from Axios is the data that we get back. And we now already know the type of the data because of the generic that we passed into here. This is why I think Axios is so useful for this. And we can simply return the data from our use query. Now, because we returned the data, we can now use it as the data that we can destructure from the actual hook. And we can also rename it to products, for example. If we now hover over this, we can see if this is the actual type from our API, or this will be undefined while it's fetching the data once the page loads, which is totally cool. Now, for now, to know if we set up everything correctly, let's simply log out the products. And of course, what we still need to do is define the actual API route, right? There is no backend serving this route yet, but that will be very, very simple to create. Let's do that in our app folder. Let's create a new folder called API. And inside of this API folder, let's create a new folder and call this products. Now, this products folder that we just created will contain a new file called route.ts. And this is important to name it that because that's what Next.js expects of us to name the file to actually make this available as an API route. And inside of this route, we can simply export a const post. So this is going to be the HTTP verb that we want to serve as a uppercase kind of word. So this could also be get, this could be delete. We want the post method to be served from this API endpoint. And this is going to be an asynchronous arrow function that's going to handle all the logic. For now, right, just for demonstrative purposes, so we can already see the products in our application, let's already query our database and then later kind of optimize this whole thing, right? But for now, we're going to say the const products is going to be equal to await db or database dot query. So that's how we call or search for data in our vector store. And we need to pass this some options like the top K. How many results do we want to get back? And I think 12 results for now is totally fine. Then the vector that we're searching for, in our case, for now, again, this can just be 0, 0, 0. We just want to show some products in our app. For now, we're going to tweak this later. And we're also going to include the metadata so we get access to that in our database result in the type right here. Perfect. Okay, now we can already return this from our API endpoint. So return new response and then JSON.stringify. So we pass these as a JSON string back to our front end, the products, and that should already work. Now there's no error handling or anything. We're going to add that later. So this is not what you would deploy to production at all, right? We're going to worry about that in a second. But for now, let's just see if everything works, if we actually get some products showing up in our console, because we should, right? We're querying the backend from our front end using React Query now. And we also created the route that answers the request we're making from React Query. So ideally, we should see the products logged out in our console. And we can already, we're not logging out the filter anymore. That's fine. Okay, and there are our products queried from the database using React Query with the metadata, the image and the name and so on. Perfect. So this is the ideal foundation for us to render out each product and actually show it in our UI. We can see everything works. We set up the front end and the back end correctly and wired them together using React Query. Beautiful. So the only thing that's left to do now to actually see the products is, well, show them. And where do we show the products? And the answer is we're going to do that right here before the main section ends and after the button and after the two closing divs. So this is where we're going to start a section. And this section is going to get a class name of padding bottom 24 and a padding top of 6 to give it some spacing from the other elements. So it's going to look nice. Now, inside of the section, we're going to create a div, and this is going to get a class name of grid, a grid-calls-1. And if you're wondering what that does, it's the grid template columns repeat CSS property, just in a much nicer Tailwind kind of syntax. And behind that, we're going to give it a gap x of 8, a gap y of 10 for some vertical spacing. And on large devices, we're going to give it a grid calls of 4. Now, inside of this div later on, the filters are going to live. And these filters are going to live inside this div that we're creating right now here. So we can even add a little comment right here in our JSX that these are going to be the filters inside of this div right here. However, we're not going to do that right now because remember, we want to show the products first so we can visually see what we're doing. And for that, we're going to create below the filters a product grid that's going to contain all the loading states, all the products and all the, product related logic. And we're going to do that inside of a UL, an unordered list. And that's going to get a class name of large call span 3. Then it's going to get a grid calls of 1 on small devices, a grid calls of 2. And on medium devices, a grid calls of 3. And lastly, a gap of 8. Now, inside of this UL, the actual products are going to live. So let's render out the products by mapping over them. We already have access to the products. Remember, that's what we call the data we get back from React Query. This is optional, however, and we're going to map over these products and then in return show some JSX right away. Now, Josh, why are these optional? Why could these be undefined? Because once the page loads for like a split second, half second, whatever, how long it takes for the network request that is made to our backend to come back. Right here, you can see the products are fetched from the backend, and this request to the backend, let's see how long it took right here in the timing. It took 133.17 milliseconds. So for that duration, while the data is not there yet, or data from React Query, the products will actually be undefined. And later on, we're going to show a loading state during that time. Right now, we're already going to show the product component. Now, let's call this the product component. This is going to be a custom component. We could inline it in the same file, but I think it's much more readable if we split this out to a completely separate component. And let's define that component because, of course, it doesn't exist yet. We're going to do that right here under our components folder. Let's create a new folder, not a file, and call this products. Now, why are we doing this? Well, because there's going to be later 3 different components related to a product, which is the loading state, the skeleton, and the product itself. We're going to start with the product itself, which is going to be called product.tsx. And the component is going to be pretty straightforward. Let's first create the arrow function, const product is equal to an arrow function. And of course, as always, export that as the default at the very bottom. Now, what are the props that each product takes? And that's just going to be the product. And we can even inline the type because that's literally the only prop we expect. It's the product. And this is going to be of type, you can probably guess, the product type from our database file. As easy as that. Now, let's get to the JSX for the product. So let's return a div at the top level in here. And the class name of this div is going to be group and relative. Now, inside of this div, let's create one more div, and this is going to get a class name of aspect-h-1, an aspect-w-1, a width of full, an overflow-hidden, so if anything kind of goes beyond the bounds of the div, it's going to be hidden by default, a rounded-md, a background gray of 200. On large devices, we want an aspect-none, And we're gonna say group-hover, and this is gonna get an opacity of 75. And on large devices, we're gonna give it a height of 80. Great. Now, inside of this div, we're gonna create the actual image that's going to be the product image. Now, what is the source for this image? This is going to be the product dot, and then you can probably guess what it is, the image ID, right? Which is pointing to the path the image is stored at in the public folder. And that's all the image ID is. This alt tag can be pretty much anything, let's say product image. And as for the class name that the image gets, this is going to be a height of full, a width of full, an object-cover, and lastly, an object-center. Perfect. Let's format the file. That is our image. And if you've noticed, we are very intentionally not using a next image right here that is automatically optimized, but I really dislike the rendering strategy the image uses. And I think the default HTML image looks much, much better in the final product. So right below this div right here, and with one more closing div to go, let's create another div. And this will contain the product name, price, and so on. So this div is gonna get a class name of margin top 4, a flex, and lastly a justify between to kind of separate the elements. And so this is the justify content property that we can apply because we're also using the flex. Now, inside of this div, there's gonna be an h3 element, but before that, I forgot, there's gonna be one more wrapper div before that. That's gonna contain both the h3 that we're gonna create in here, and the h3 is gonna get a class name of text sm for small, and a text gray of 700. And everything that's going to be in the h3 is going to be the product.name, as easy as that. Now, below the h3, we're going to create a p tag, a paragraph element with a class name of margin top 1, a text sm for small, and a text gray of 500. And inside of this paragraph, we're going to say size, and then dynamically the product.size.to uppercase, just like this. So this is going to be like S, M, or L, or XL, XS if you wanted to add more sizes. And secondly, with a comma separated dynamically the product.color. So this is going to be like black, beige, white, and so on. Perfect. After the closing div with two more closing divs to go, right here, we're going to create a p tag, and this is going to get a class name of text small, a font dash medium, and a text gray of 900. And inside of this p tag, we're gonna say the product.price. How much is the product? There we go. Let's save this product component because we are already done. That's it. And we can now go ahead and import that in our page.tsx. Now, of course, we're still gonna get an error right here because this product expects a prop. And why is the import not working? I suspect. Yeah, okay, so we have the type product and then we also have the component product. Of course, that can't be the case. So how about we fix this by aliasing the product type, let's say as T product, for example. So that's the type product because this is actually a type under the hood. So we can use the T whatever convention in TypeScript to rename it. But we are using the type right here, for example, so we need to replace the query result with the actual type. Weird, because in the product that in the project that I made, this didn't give me an error, but apparently here it does. Anyways, because we're rendering out the product component right here, this expects a property, of course, which is the product. We can simply pass in for each product that we're rendering out. We get access to the product right here in the function, and we can pass in the product.metadata. And we can tell TypeScript, yes, we are sure this exists. Now, why can we tell TypeScript, yes, we are sure this exists? The reason is that we include the metadata wherever we fetch the data right here, right? So each product has metadata, which is like the name, price, and so on. And we're explicitly telling our database, yes, give us that metadata. So we are sure this will exist at runtime. Perfect. Let's save that and let's actually see what happens. Is our server started? Yes, it is. And there we are. There are our products. Beautiful. From the seeding script into our database, to our API route, to our front end, just like that. And now we can very visually see all of the changes that we're going to make, the filters and all the, like the sorting filter, for example, and all the filters that we are about to build right now. Now, while we are doing the products, how about we quickly implement also like the beautiful loading states for the product? Because if we refresh the page right now, it looks kind of it doesn't look good. Let's be real here, okay? I mean, it looks fine once the products are there, but the loading could look a lot better. So let's quickly do that because as you'll see, this is really, really straightforward. So the way we're gonna do this is let's go into our products folder in the components, create a new file called product skeleton.tsx. And this is gonna be const product skeleton, an arrow function as always that we export default at the bottom, the product skeleton. Now, all this component will do is be basically like the product, right? It's gonna mimic exactly the height and size and everything of a product, but it's not going to contain actual information, but just a loading skeleton that we can show while the stuff is loading. For that, we can return a div at the top level with a class name of relative, and here comes the important part, animate-pulse. That's what's gonna give us this loading kind of aesthetic. This is just a CSS animation under the hood, and it's super, super helpful. You're gonna see that here in a second when we actually use this component. Inside of here, let's create a div with a class name of aspect h1, an aspect width 1, a width of full, an overflow dash hidden, a rounded dash MD, a BG gray of 200, so the background color. On large devices, an aspect dash none, and lastly on large devices a height of 80. Now as you'll notice, this actually mimics the class name we wrote earlier for the actual product. That's how we know it will look the same, because after all you can just kind of, the way I usually do this is copy and paste the actual thing that you're trying to implement a skeleton for, and then remove all the dynamic parts like the size and so on and replace them with a just div that is gray background, so it looks like the loading state. Now, to achieve this, we can put a div right here, third one, and this is actually going to be self-closing. We don't need anything inside of it, and let's give it a class name of height full, a width full, and a background gray of 200. And this is going to be the image replacement on the product skeleton. Below the closing div, and after the self-closing div as well, with one closing div to go, let's create one more div. And this is going to get a class name of margin top 4, a flex dash call, and a gap of 2 for some separation, and then two self-closing divs in here. Let's start with the first one. This is going to get a class name of background gray of 200, a height of 4, and a width of full. And then we can hold Shift, Alt, and arrow down. Bam, there we go. We just copy pasted that down. And now let's implement this. While the products are loading, we want to show this loading state. And it could not, I'm not kidding, it could not be easier with React query on how to do this. So essentially what we can do is turn this current rendering part into a ternary check. So if we have products, then we can map over these products unconditionally because we know they exist now, right? Because of the guard clause right here, we can check if they're not undefined, then we can render over them and show all the products. But if they are undefined, while they are, we're actually going to map over a new array of a length of 12, where each element we're gonna fill with a null value because we don't care about what's in the array. We just want 12 elements to map over. And for each array element, we're gonna map over this. We don't care about the first value that we get back in the callback function, but we do care about the index of the current element that we're mapping over, because that is going to represent the key for the product skeleton component that we are going to put in here. So that's gonna be the key, and that's gonna be the index. And of course that needs to be products in the plural. There we go. Oh, and it seems like I messed up the order. It needs to be exactly the other way around, because currently what this means is if we have products, if the data is there, then we're going to show the loading state, and else we're going to show the product. So of course it needs to be the exact other way around. Let's quickly replace the thing right here, the loading state, with the actual product logic, and then cut this down and paste it right here. So if we have products, then we are mapping over the products, and else, that's what this means, and we're going to show the loading state. Let's hit save and see if that works. So once we are reloading the page right here, you should be able to see, yes, it kind of works, but did I mess up something with the image? Oh yes, and I did mess something up, and that is I messed up these two first class names right here. We need to replace them, the aspect h1 and aspect width 1. So the intent here is that essentially we're making the product image a square, right? And in order to achieve that, we can simply say aspect dash square. This is the better way of doing the exact same thing. And if we save that and reload the page, then we will see, yes, this actually now works with the loading animation. And if we go into like very full screen and reload the page, it's a bit easier to see the loading states right here. Very, very nice. They look awesome. And you can see on the left-hand side right here, we already have space for the filters that we are about to create. Very, very nice. So we can exit out of the product skeleton, the product, the route.ts, providers, layout, whatever. We can close out of all of these, and let's navigate back into our main page.tsx, because this is where the magic is about to happen, which is where we're going to implement the filters right damn now. Okay, so the filters are going to live right here, where we already marked this inside of this div element. Now, this div element is going to get a class name of hidden, and on large devices, it's going to get a class name of block. So it's not going to be visible on mobile, but mobile is going to be a bit different. Then, inside of this div, we're going to put an unordered list element. It's going to get a class name of space y4 for some vertical separation, a border -b for bottom, a border gray 200, a padding bottom of 6, a text SM for small, a font -medium, and lastly a text gray of 900. Now, inside of this unordered list, we want to show some categories that you can browse through on our website. Essentially, this could be like, for example, hoodies and shirts and pants and everything that you're offering on the website in the case of an e-commerce application. And in order to make that happen, we can define these subcategories at the very top of our file. Let's put them right below the sort options, for example. Let's say const, and then again in uppercase subcategories, because this will never change. That's how we indicate this is a constant value. And this is going to be nothing else than an array of elements. Each element as an object right here gets a name. The first one is going to be t-shirts, just like that. It's going to get a selected property, and the t-shirts is going to be true. And we can also pass it, just as an example, an href value that if you click on this, then it will take you to that product page. Of course, this is just for demonstrational purposes. And using Shift, Alt, and arrow down, we can copy this down once, twice, and thrice. I don't know what that's called. And then replace the t-shirts in the second one with hoodies and change the selected to false. The third one is going to be sweatshirts, and the selected is also going to be false. And the last value is going to be the accessories. It's a very hard word. Do you spell it with 2 C's? I'm not even sure. It's a very weird English word. And the selected value is going to be false. Great. So now we can actually show those subcategories in our code, and that's going to happen in the unordered list that we create. So in this list, we can simply map over these subcategories, categories.map. And for each category, that's what we're going to name each object in this array, we are going to render out some JSX right away. So in the normal parentheses, just like this. And we need to dude, the syntax is completely messed up here. There we go. And we're going to close out of that like that. Okay. Now, inside of here, we're going to render out an li element, because if we're in an unordered list, we expect the first or the top level element to be an li, a list element, and it's going to get a key of the category.name. So that's going to be like hoodies, t-shirts, and so on, just a unique value to identify this li element. And inside of here, we're going to render out a button. This button is going to get a class name of disabled, then a cursor not allowed. There we go. So we can separate this with a colon for conditional appliance. So what that means, if the button has now a disabled state passed to it, then this cursor not allowed class name will be applied. That's just the Tailwind syntax to do just that. It's a really nice syntax. I like it a lot. Then afterwards, we're going to pass it a class name of disabled, same thing, colon, opacity 60. So we indicate to people that this is not clickable if the button has a disabled state. Inside of this button, we're going to render out the category.name, so like t-shirts, hoodies, and so on. And also this button is going to get a conditional disabled state, and this is going to be the not category dot selected. So if the selected value is false, then the button will be disabled. I think it's just easier to see if we take a look at this, how it looks visually. It looks just like this to indicate there are multiple categories. But of course, since I already prepared all the t-shirts, but not like hoodie, sweatshirts and accessories, that would have been just way too much work for essentially no purpose, because we want to learn the code and not how to design hoodies and sweatshirts and accessories in Photoshop as well. And we are disabling the click on those and only allow for the t-shirts that I actually made the assets for. Beautiful. So that's the first kind of filter. I know it's more like decorative, but now we're going to get to the actual functional filters that we really care about. And we are going to do that right here under the UL element and before the closing div element. And we are going to do this inside of something. Let's go into our terminal called the accordion component by our UI library. Accordion, let me show you what this does. Basically, it looks like this. We can expand each section and it's going to expand beautifully animated, and that is going to contain our filters, and we're going to make use of this component for our filters. So let's install it. npx chat cn-ui at latest add accordion. There we go. Make sure to spell it correctly and then hit enter. That's going to install the accordion component into our app, in the same approach with all the other components into our UI folder right here under accordion.tsx. And what that allows us to do is to now get started in actually using the accordion. Now, how do we do that? Well, let's start with the accordion component and import it from our own components folder. And this accordion expects a property that is type, and you can choose between multiple and single, but it essentially means how many filters can you expand at the same time. You see right here, this is a single because only ever one section is expanded at the same time. When I click a new one, then the old one is closed, but we of course want to allow multiple to be open at the same time, and with a class name of animate-none. Now, inside of this accordion, the first filter we're going to work on is the color filter. So let's add a quick comment here in our JSX to just make sure that everybody who reads through this file can very easily see what we're doing. It's the color filter that's about to follow as the first accordion element. So let's create it. The accordion item, right? This is like kind of the, well, basically it corresponds to one of these sections you can see here on the right-hand side. That's what we are creating right now. And this expects a value prop. This is going to be the name of the section. And because you could, for example, pass a default value into the accordion, which values should be default opened. And that's how you identify certain sections of the accordion. Inside of here, let's create the accordion trigger, also from our own components and not from Radix. And this is going to get a class name of padding y3, a text of sm, a text gray of 400, and on hover a text gray of 500. So a bit darker just for some hover interaction. And inside of this animation trigger, inside of a span element with a class name of font-medium and text gray 900, there we go, we're gonna say color. Now let's save that. Let's start back up our development server and let's already see what this looks like. Because what we expect to happen is for an accordion to show up here on the left-hand side in our filters. Let's refresh the page. There we are. And if I zoom in a bit, you can see that we have the color right here. And if we click it, then it looks like the section is expanding because the chevron right here, the arrow, is kind of flipping around as we click it. But in reality, of course, nothing is showing there because we haven't set the content that should show when you click on the accordion trigger. How do we do that? Well, same thing as for the drop-down menu. If you remember that, we had the trigger and we have the content. And same exact really clean API for the accordion. We simply pass the accordion content in here. Now, this content gets a class name of padding top 6 and also an animate-none. And inside of this accordion content, we are going to put an unordered list. This will get a class name of space y4, just again for some vertical separation of the items. It's just looking a bit nicer. And inside of here, we are going to display the color filters. Now, one approach that I really enjoy to kind of define the filters that should be shown in our application is at the very top of the file, just like with the sort options. So what does this look like in practice? How do we actually define the filter? Let's say const color underscore filters. And this, again, all uppercase to indicate that this is a value that never changes. Super common convention is going to be an object, and this is going to get an ID of color. This is how we're going to identify the filter on the back end, a name, and this is what's shown to the user. So we can say in like the upper, it's not uppercase, but where like the first letter is uppercase, I guess. So it looks nice to humans. And then lastly, the options, and this is going to be an array. Now, which options do we want to provide to filter by? Each option, first off, gets a value, and that's going to be, for example, white, right? This is the actual color, and we're going to use on the back end as well. And the second thing we want on here is the label. And this is again what's going to be shown to users. So this is how we internally identify stuff through the value. And this is what's shown to our users. And now comes the trick. We simply go into this line, hold Shift, Alt, and arrow down, and press the arrow down once, twice, thrice, and fourice. I don't know. Anyway, so we have the white, label white. Let's create the beige, and label will be beige with the uppercase B. Then we're going to go for blue. Label, you can probably guess, is going to be blue. Last or second to last is going to be green, with the label going to be green. And the very last color we're going to have in our app is going to be purple. And the label, of course, is going to be purple as well. And for the options, we are going to add an asConst as well to tell TypeScript these options will never change. Now, if you actually decide to add a custom color to your page later, of course that is possible, right? But not by pushing into this array. That's all we're saying with the asConst. You can't push into this array, but you could simply go ahead and add a new color like this. If you wanted to have like a yellow, for example, label, yellow, there you go, you just added the new color, you know. But all we're saying with the asConst is a TypeScript that, hey, this array will not change if you don't explicitly put the object in here, like I just showed you for the yellow color, for example. So after doing that, let's finally show this filter to our users. And we do that in the unordered list by saying color underscore filter, filters dot options dot map. And each option just corresponds to the color we just created, where we get access to the option and also the option IDX, the index, and can right away return some JSX from here. Looks a bit messy. We're going to format this in a second. And of course, because we're in a list, we also want to return an li element at the very top level. And because we're mapping over something, this also needs a key, which is going to be the option.value. Otherwise, you're going to get like a React error in the console, which is, it's not bad, right? It doesn't affect runtime, but it looks not nice, you know, and we can just avoid it. So we're also going to pass a class name in here. And this is going to be flex and items-center. And inside of this li element, we're going to put an input element. The type is not going to be text. This type is going to be checkbox. And the ID of this input is going to be a dynamic kind of composition. So as a template string with the backticks right here, we are going to pass in the color dash and then dynamically insert the option IDX. Now you might be wondering, Josh, why are we doing this? Why are we passing an ID in here? And you're going to see that as soon as we finish the input. Trust me, it's going to become very clear why we do this. Before we do that, let's quickly finish this. Let's add a class name on this input. And the class name is going to be a height of 4, width 4, rounded, a border gray of 300, a text indigo of 600, and on focus, colon, we're going to say ring indigo 500. There we go. That's going to be the entire class name we're going to apply to our input element. Now, why are we assigning the ID? What's the reason behind that? And the reason is that we can create a label for this specific element that's going to describe the filter that we're applying here. So, for example, the label gets an HTML4, and we can dynamically pass the value in that we assign as the ID, right? So the ID is going to be the exact same. You can copy and paste it. And we are telling HTML that this label will be for this exact input element because the ID matches the HTML4. That's why we're assigning the ID to the input. Now, this label is going to get a class name of margin left 3, a text of small, and also a text gray of 600. And inside of this label, we can put the option.label, so the text that will be shown to the user for this specific filter. what does this look like if we save this? Let's expand it, reload our page, and if we now open this color filter section, we can see all the filters show up here: white, beige, blue, green, purple. And the beauty of the label is that even if we click on the name, right, which is the label, the checkbox will still be checked. So we don't have to click the checkbox itself, but clicking the name of the filter, as users often do, is perfectly fine as well. That's why the label here is so useful. That's why we assign the ID. Okay, now the question is, right, what should happen when the user selects a color, like logically? Because right now, no filters are actually applied to the product search. So logically, what should happen? And the answer is just like with the sorting filter, right? We also want to keep track of this in state, so we can send it along in the request to our backend. That actually determines the filters that are applied to the products, right? So the way we do that is by adding a field right here in our filter, because that's where we are going to save this. So the field we're going to add is going to be the color, right? And this color can either be, well, it can be anything. This is an array of strings. We're going to define this in a second. However, we can definitely improve the way we work with a state in TypeScript, because as you can see right now, we can literally pass any string in here. There's no sense of type safety whatsoever. If we were to pass anything as a color, that's totally valid in our current setup, and that's horrible. We don't want that. We want full type safety for the state. How do we achieve that? Well, by one certain library that we're going to use, which comes in super clutch. And that library, let's pause our development server for a second. That library we're going to use is called Zod. So pnpm install ZOD. It's called Zod. And this is a schema validation library that integrates extremely well with TypeScript. And I use it in a lot of projects. Now, inside of our source/lib folder, this is where we're going to create a new folder right now and call it validators. Because Zod is a schema validation library, that's exactly what it does. It helps us to validate certain data shapes, right? You're going to see exactly what this does in a second. Inside of this validators folder, for now, let's create a new file and call this product-validator.ts, because that's how we will validate the shape a product has, for example, that is sent to our API in the backend. Now, inside of here, first thing we're going to do is import z from Zod, because this is what's going to allow us to actually make use of the library now. And now you're going to see the beauty of Zod. So we can say export const, and then we can define the shape of what a product should look like. And let's call this the product filter validator. And this is going to be equal to a z.object. And this is a function that we invoke with an object inside of it. And in here, we define the shape of a product. Which properties should a product always have? And that's, for example, the size. What is the available values for the size? Well, it's a z.array. And in here, this is going to be a z.enum. So we're only allowing very certain properties that we pass into this enum right here. What values do we allow for the size? Well, we can define that at the very top right here. Export const available sizes, also in caps, because this is going to be a constant value that never changes. This is going to be an array, and each element in here, these are going to be S, this is going to be M, and this is also going to be L. These are all the values for sizes that we allow in our app. And of course, as constant, because these won't change unless we explicitly add an element to the array like so. But just so we can't call the push method on it, right? Without the as const we could, but that should never happen because we know this won't change. Now, we can pass the available sizes into the z.enum, which will create an enum from our available sizes array, and let Zod know that these three values right here literally are the only valid values for the size. This approach is beautiful because it allows us to get full type safety on the front end and enforce the types on the back end as well, right? For full schema validation, which is really, really nice. That's the reason why we're doing the same thing for the color. The color is going to be a z.array, again, a z.enum inside of here, so very specific things we're allowing in here, and we can simply copy and paste down the available sizes using Shift, Alt, and arrow down, call it the available colors. And inside of here, of course, we want to change the values, right? This is going to be for example, white. This is going to be beige. This is also going to be green. Second to last is going to be purple, and then the last element is going to be blue. So you recognize these colors. These are the colors that we allow in our app, of course, again, as a constant, which means we now can pass them into the enum to create our product schema validator. So later on, when somebody sends a request to our backend, we can make sure that the only colors they can pass in that request are these ones in the array, and other values will be rejected, right? This is very, very, very helpful. Right after that, we can define the sort, and this is going to be a z.enum directly. This is not going to be an array, but instead, of course, when you pass the sort, just as a comment for you, you don't need to write this down. This is going to be like either S, or this is going to be M, or this is going to be L, but of course this is not going to be an array. This is either going to be none, for example, or this is going to be like price ascending, but it's never going to be multiple at the same time. So an array structure does not make sense at all here. So that's why it's directly in enum. And we can define the available sorts by saying export const available underscore sort. And this is going to be an array of none, of price dash ASC for ascending and price dash DESC for descending as const, of course, once again. And then we can simply pass the available sort into the enum, and we're almost done with our product filter validator, because the very last thing we want to do in here is the price. And the price is interesting because the price is going to be different than all the other ones. Like why? You might be wondering. Let's move this into a side-by-side. Why is the price different? Because if we take a look at the price structure, like the price filter, right? What are the options that you can pass? For example, under 20 euros, right? Or dollars, or whatever your currency is, right? Under 40 euros and so on. What does this mean? What is the structure of a price? It's very different than a string array. A string array doesn't make sense here. You can't pass, or well, you could pass, but it doesn't make sense to pass literally under 20 euros as a string to the backend. The backend won't know how to handle that. That is why the price is actually not going to be a string, but it is going to be an array of numbers. And to be very specific, let me get out of here. Hello, I don't want to draw an arrow. What the hell? Just get rid of that arrow, dude. All right, so anyways, a price is going to be an array of exactly two numbers called a tuple. For example, from 0 to 20. This data structure really well represents what we're trying to do with a price, where each price is from to, right? It's kind of a range of price, or 0 to 40 if we wanted to allow products from 0 euros to 40 euros, or 0 to 100, etc. You get the point, right? That's why the price is very different than the previous ones, but defining it in Zod is not harder than the previous ones, right? We can simply use the z.tuple to tell Zod that this is going to be like a number and then one more number, so two numbers instead of an array. That's what a tuple is. And we can simply pass this in an array of z.number and z.number and invoke that as well. So Zod now knows that this is a pair of two numbers. And that's already it. Now, what defining this schema does for us is basically twofold, right? First off, enforce shape on backend. We can make sure that the data we receive on the backend actually matches exactly the shape, or we will reject the request. So for security reasons, this is very nice. And then the second reason is that we get full type safety on the front end, right? We can now pass the generic that we can infer from the schema to the state. Sounds abstract, I know, but let me show you how this works, and let's do it together. It's very easy. We can export a type, and let's call it product state. And this is going to be equal to the z.infer. So this is a utility that Zod provides to us to infer the type from the kind of JavaScript, TypeScript syntaxy schema, and to generate a TypeScript type from it. This takes a generic, and that's going to be the type of product filter validator. Just like that. And boom, we now get a TypeScript type from our schema that we can use to validate stuff at runtime, right? That's really, really cool. And we're going to do one little change to this. So for now, let's mark this and cut it out because we're going to need it in a second. But we're going to wrap this in an omit utility type from TypeScript because we're going to replace one property in here. Because Let's paste this back in, and we are going to omit the price value from this. Why are we doing this? Because while all the other properties are gonna be represented as is in our state, the price is not going to be, because for the price, the user is gonna have two options. There's gonna be like under 20 euros, there's gonna be under 40 euros, there's gonna be any price, so the user doesn't care. But the second main option is going to be a custom value, and we need to keep track of whether this is currently a custom value or not. And currently the price does not allow for that. So we need to modify our type to be able to tell in state, is this currently a custom value or not? So we can display some JSX conditionally for that, right? And currently in the type, that is not possible. So we will replace the current type, and we can do that with the omit TypeScript utility type, and remove the price and now replace it with a new property. So and object, this is going to be the same kind of name. This is going to be the price because that's what we're overriding now. And we're going to override this with the is custom, and this is going to be a Boolean value. And secondly, the range, and this is of course going to be a number tuple, as we discussed earlier, right? So all we're doing is telling TypeScript, yes, this will still be a tuple, right? Same thing, but now separated into a range and an is custom property that we're going to keep track of in state. And that's it. We can already take the product state and pass it as a generic into our React state right here to make this type safe, and also of course need to import it. And check what happens. Type empty string is not assignable to type white, beige, blue, green, purple. We now get full type safety for the values we can pass in here. And now of course, by default, we want to enable all the colors. Everything should be selected like as a default filter. So let's pass all the values in here. So beige, blue, green, purple, and white. Of course, you could also abstract them somewhere else and then pass like something like default colors in here. I don't think that's more readable, though. I much prefer this approach of directly passing the strings. And as you can see, that's not even it yet. We're also expected to pass in the price with full type safety in here as well, with the is custom and range. That is beautiful. So for the is custom, by default, we're gonna pass false. And for the range, let's abstract this into a constant value right here, because we're going to use it in multiple places. I think this is more readable if we put it just here, but I think let's define a default underscore custom underscore price. And this is going to be a tuple of 0 to 100 and we're going to cast this into a TypeScript type, which is going to be number and number right here. The reason we're doing this is if we're doing this, right, this type is a number, but if we didn't cast this, then it would be a number array. So TypeScript doesn't know, it will always be too long. But if we do this as constant, then also the numbers themselves are going to be inferred. And that's not always the case. The numbers itself can change, but what won't change is that this is always two numbers. So we're casting it as a number array. So TypeScript will always know the number can change, right? It's not always going to be 0 and 100, but the length of the array will not change. That's why we're doing this. And this is going to be the custom range we pass in for the price. Now, of course, that's still not going to fix the error just yet. We're also expected to pass the size array. And just like with the colors, we can allow all the sizes, which is going to be L, M, and also S, to be selected as the default filters. And after passing those, this looks super nice. I really like this API design. It's super readable because you can tell right away when looking at this which filters are applied by default. This looks really, really nice and intuitive. And to actually make use of our filter, right? Do you remember the color filters that we're mapping over? How do we now keep track of them in state? And the answer is we do that in the onChange handler of our checkbox input. So we can simply pass an onChange handler into here, and this will be a function that is being executed. Now, we could inline define the action that should happen, but because we're going to make use of the same function, the same onChange handler as well, not only for the colors, but the same logic will apply to the other filters. Like, for example, the size filter, right? Same logic where we have an array of string values that are then being filtered, right? Same thing for both of these. We can abstract this into one function and make our code a lot cleaner that way. Let's call that function the apply array filter function, because that's literally all it will do. It will apply an array filter. So this will only be applicable for array values. And this is going to be an arrow function that takes some properties, or I guess parameters would be the better way to call it, right? And this takes two things. So the category, and this also takes the value. So the category is going to be, for example, the color or the size, and the value is going to be the actual color, like the beige or white as a string, or the S, M, or L as a string, right? That's why we're kind of differentiating between those two. And we can tell TypeScript what these are. The category is going to be of type, and we're going to make use of a TypeScript utility type here. This is going to be the key of, and then the omit TypeScript utility type. And in here, we can pass the type of filter and remove both the price and also the sort property, because these are not array values, right? If we take a look at them, this is not an array of strings, and this isn't either. Only the size and the color are. And this function, the apply array filter, is specifically for array values. And by the way, I completely messed up the syntax here. Of course, this is not going to be inside of the function body, right? This is a TypeScript definition. So let's cut this out using Control X and put it right here where it belongs, where we can tell TypeScript the type of the parameters that we expect here. And then the value, as I said, is going to be string. Like this will be, for example, the S or the M for the size, or this could also be like the white or beige and all the other colors that we allow. So you get an idea of what this is, right? And the logic that's going to happen inside this apply array filter is pretty straightforward, because if we imagine what a filter looks like in state, right? This is basically an array of white and let's say, for example, beige, right? Let's say we allow two colors right here. This is our current filter. Then imagine the case where the box with the value of not purple, but purple is now checked, right? This filter is now being applied. What's the logic that should happen in the apply array filter? First off, we want to check, is purple already in the array? Because if purple is already in here and the purple filter is checked, right? If it's already checked, let me show you that right here, and we check it again, it will be unchecked. And therefore we want to remove this element from the array, of course, right? And if purple is not checked and then we check it, or I guess purple would be here, and then we check it, then it should be added to the array, right? So all the logic that this apply array filter function handles is the check of, is the element already in the array? And if it is, then remove it. Or if it's not in the array, then we add it. That's literally all this apply array filter does. And the logic in code is as straightforward as that explanation. First off, we do a check, is the value already in the array? Is purple already in the array, right? So let's call this the is filter applied. And this is going to be the filter at the category. So this is going to be like color or size, for example, dot includes, and then the value as never. Right? This as never is just a TypeScript thing. If we didn't do this, we would get some weird TypeScript error that really does not matter. TypeScript doesn't understand what's going on here, so this is totally fine to add. And all the is filter applied does for us now, it tells us, is the value already in the array or not? Does the array already include the value? And if it does, right? If is filter applied, that means we should remove it from the array because we're unchecking that filter. So we're going to set the filter to whatever it was previously. That's what this means. We spread in the previous values of the filter, and then we change the category. And we do that by putting it in angled brackets, the category in here. So this is equal to, for example, the color, right? Or this could be the size, but it is dynamic to whatever is passed into the function, right? Because we can't hard code the category here. That would literally search for the string of category in our filter, which doesn't exist. We only have color, price, size, and sort. There is no category in here, right? That doesn't work, but instead we mean the color or the size dynamically. And we do that using this syntax right here by putting it in angled brackets. And in here, we're going to say the previous category dot filter. And for each value, for each v that we have in here, we're going to filter out the value by checking if the v is not equal to the value. So basically, maybe a bit abstract if you're not too familiar with how React immutability works. But essentially, if, for example, we are applying the color category, right? If the category is color, then we're setting the value of color to the entire array that it was previously, right? The previous at the category, but we only filter out the elements that match our current term, which would be purple. So we're setting the same array to what it was previously, but without the purple element. That's how we change the state immutably. That's how you kind of work with state in React. And then the opposite should happen if the element is not already in there, right? If we check the purple box and it's not in the array, then this should be a filter that is now applied, right? So if purple is not checked and now we check it, then now we also want to show purple products. The way we do that is by now putting it in the array in this if statement, right? So in the other case where the filter is not already applied, we're going to add the element by setting the filter to whatever it was previously, right? So we spread in the previous values. And again, dynamically at the category like size or color, we basically now want to add that property into the state. How do we do that? By setting the category to whatever it was previously, right? We spread that in the previous at the index of category. And then at the last, as the last element of the array, we append the value. So all we're doing is taking the original kind of array that was there and now adding the purple value to our state at the very last index of the array if it wasn't applied before, right? That's what the if check is for. So now it will be in our array. And what this implementation of apply array filter now does for us is really beautiful, because as we go down to where we want to apply the filter in the onChange handler, we can simply call the apply array filter function that we have just defined and pass two things: the category, which is going to be color in this case, right? Because we're in the color filters right here, right here, color filters. And then this is also going to be the value, the option dot value. And the entire logic of is the element already in the array or not, etc., is being handled by our function, and we don't need to worry about it here. And lastly, to turn this into a controlled input, we can simply pass in the checked property, which determines if the checkbox is marked or not. And this is going to be the filter dot color dot includes and then the option dot value. So if the current state includes, for example, purple, then yes, the checkbox should be checked. And if it does not include the color, then it should be unchecked. That's all we're saying here. And let's just demonstrate this, right? Let's log out our filter state so we can see what happens, right? Let's console log the filter, format our file, save our file, and then head over and actually see this in action. Let's turn this into full screen, go into our console. Let's reload this really. Oh, and of course, well, we should start up our development server for this to even work. Let's say yarn dev, let that start. And then let's take a look at what happens in the console, because now we should see our filter and always the correct values applied for the color filter that we've created. So let's let this load. It seems like the server has already started. Let's refresh the page. And in Next.js, this sometimes takes really, really long. Especially like the first loading, once you start up the server, goddamn. All right, there we are. Okay, let's clear the console. And again, this takes so long, man. Let's refresh this. There we go. Okay, we get an error right here. What's the problem? Each child in a list should have a unique key prop. Okay, we're gonna fix that in a second. No problem. Right now, as we select or unselect the white, for example, we should see the color array not contain white anymore. And if we recheck it, then white should be back, there we go, in the array. Beautiful. So if we uncheck like 4 out of the 5 things, then only purple should be left in the array. Let's check if that works. Color, only purple. Beautiful. This state is now ready to be sent to our API. At least the color one, right? We didn't implement the size one yet. As you can probably see, there is no size option in our filters, but the logic for everything is now in place. And this is a really, really nice, readable, maintainable API design. Okay, that looks very, very nice. Let's close out of the console and scroll down to the color filter we just implemented. Because the thing is, the color filter really is the entire logic behind the other filters as well. Now the price filter will be slightly different, because if you remember, it involves like this custom kind of price or range, right, that the other filters don't have. So the price filter, while it will still build on top of the logic of the other filters, the price filter is the only one that's going to be a bit different. But For example, what's really similar to the color filter is, as you can probably imagine, the size filter, because it's also just an array of strings, right? So what we can do is go ahead and mark the entire color filter accordion item using our emit outward, like balance outward hotkey that I showed you in the very beginning, which is Control M, or you can also just manually mark it if you want. And then we can copy and paste this down using Shift, Alt, and arrow down. Bam, there we go, as easy as that. Let's kind of separate this, and let's also add a little comment for us in the JSX to know what this is. So these are going to be the size filters now. Now, what changes in the size filters? Let's open up the page and close out of that. Of course, for one, the name, right? This is not color anymore. This is going to be size, pretty obvious. And then in the accordion content, instead of the color filters, we're going to map over the size filters. However, if you might, as you might have noticed, they don't exist yet, but they're also going to be super similar to the color filters. So what we can do, for example, is using Shift, Alt, and arrow down, also copy and paste the color filters and change the name to be size filters, and then of course adjust them as we need. And I really like this approach of going about things, because at the very top of the file you have all the filters listed and grouped together. If you wanted, you could even put them in a separate file, but I prefer them to have them right here. And then you can always just add a filter, anything you want, as easy as kind of copy and pasting this down. And I just really like this approach of going about things. So the ID of the size filter is going to be size, and the name we're going to display to users is going to be size. As for the options, we're only going to have 3 options, and that's going to be the value S with the label of S, the value M with the label of M, and lastly the value L with, of course, you can probably guess, the label of L. And this is also going to be a constant. But the entire object is going to be a constant, not just the array. So we're going to move the S constant from here over to here. Now with these size filters, I think we are already kind of set, right? Let's go down to the color filters. They are right here. And as we scroll down, we get to the size filters that we just created. And we can replace the color filters that we were mapping over with the size filters. Now, what changed? We are getting an error down here, for example, and that's awesome because the error should happen because argument of type SMRL is not assignable parameter of type white, beige, blue, basically any color, right? So TypeScript is telling us, hey, you didn't properly adjust this to be the size filters. This is still for the color filters. For example, in the ID, right? We need to change this to size. This is not for the colors anymore, but the input as well as the label are now for the size filter. And same thing here. We're not in the filter.color anymore, but of course the filter.size. As easy as that, we can simply change this. Same thing here for the category, completely type safe. How nice is that? Change it to the size, and there we go. That's literally all the changes we need to do. Let's hit save. Let's pull up the website, and this is not a proper side-by-side. There we go. And there are our size filters, just like that. However, one thing very apparently still doesn't work, and that is right here, the accordion item value. Because what happens right now, if you try this out, if you close the color, you also close the size and vice versa, right? This should not happen. And that's because both of these are still marked as value color. So we need to change this to size and then hit save, and we are golden. So now we can, if we restart the page, separately expand the individual filters and then select the products based on it. And if we take a look at our console, because of the function we just wrote, the array logic function for the state updates, we're going to see as we hit them, the state is updated and the correct size is right here in the array and in a perfect state to be sent to our backend for actual data fetching. Very, very, very nice. Now let's do this one more time for the most advanced filter, which is the pricing filter, because it involves a custom option. So let's mark the entire size filter section. And once again, using Shift, Alt, and arrow down, copy and paste it down once. There we go. And we can also just comment this as being the price filter just for us, so it's easy to kind of see what's happening here. Now, of course, the value, first thing we're going to change to price. Same thing as the label on the accordion trigger, what you press to expand the filter, right? That should be price as well. And just like with the size filters, we also want price filters where we define which filters are available for the price. Now, the basic structure is going to be similar. Let me show you what that means. Let's define a const price and then underscore filters. And this is going to be an object, and we can already mark this as const for later. So we don't need to remember to do that. Now the ID is going to be price. And of course, this will also get a name just like the other filters, like the size right here, for example. This is going to be price. Now the options are going to be an array, just like the other filters, just like this, of objects, where each object gets a value and a label. But the value, for example, in the first object that we're going to create, is not a string like in the other filters, right? Instead, the value, as we talked about earlier, is going to be a tuple, an array that has exactly 2 members inside of it. So the value for the first option will be 1 to 100. So this will be a product price of $0, or did I say 1? This should be 0, right? So 0 to 100. So a product price of $0 to $100. That's what it means. And then as the label, we can choose, for example, any price. So because no product in our catalog is more expensive than $100, euros, whatever you want as the currency, this will include all the products we have in our shop. Now, second option is going to get a value of 0 to 20. And then as the label, we're going to say under 20 euros or dollars, whichever currency you prefer. Now we can mark this, copy and paste it down once using Shift, Alt and arrow down, and change the 20 to a 40. So as easy as this, we just created one more step in our pricing filter. And the last option, as you saw in the very intro of this video, is going to be custom, right? Where you have like the slider to customize the option yourself. And that will actually be defined in the JSX and not inside of the price filters. It just doesn't make a lot of sense to define it here. So the custom option defined in JSX. We can just add a little comment here that explains where to find the implementation for this. That's going to make it very easy for anyone kind of looking through our code to see how it was being written. So once we scroll down to the actual price filter, the entire first part, right, is going to be very, very similar. So we're still mapping over the price filters. And why does this give us an error? Did you mean option? Oh, did I make a typo? Yes, this should be options in the plural. There we go. And now the error down here should be gone. Yes, it is. Perfect. Okay, so we're still going to do pretty much the same thing, but the key is going to change to be the label, because a key cannot be the option.value as a read-only tuple, right? That doesn't make sense as the key, so we're going to use the label. Of course, we need to change both the ID and also the HTML form, so we can change this to price. And what's fundamentally going to change is the onChange handler. Because this is not an array, right? We don't need to apply the same thing that works for the array. In fact, we just can't. Instead, we're going to set the state here manually. So we're going to set the filter state, and we can directly implicitly return an object in this syntax right here by wrapping the function curly braces inside of parentheses. Now, before we write the actual logic, we need to receive the previous state that React gives us access to. And we can simply spread in the previous state and only update the price state. Now, as you might know, the price has 2 properties. There is custom and range. And these are going to be representing the options that are non-custom. So if you look at the price filters, these are non-custom. These are pre-chosen options. This is not a slider where you can enter a custom range. So the isCustom property is going to be set to false. Only when you use the slider to define the price, then it is going to be true. And the range is going to be an array where we spread in the option.value, which is basically the tuple, right? Why are we not using this directly? Because TypeScript basically complains that, hey, you can't use a read-only array here. So technically, code-wise, this is totally fine, no problem at all, but just TypeScript will complain. And to make TypeScript, well, happy, we can simply use an array and just spread it in. So it's basically a clone of the values that is not read-only anymore. really just a TypeScript thing. And now as for the logic to when this should be checked or not. So first off, when should this be checked? Well, if this is not a custom value. So if not filter.price.is custom, because if we have a custom value, then there's no way this could be checked, right? So basically there's going to, and why does this keep switching away from a side by side? Anyways, basically there's going to be 4 options, right? There's going to be any price like this. There's going to be sub 20, so under 20 euros. That's going to be the second option. Then there's going to be under 40, and then there's going to be the custom option, right? So custom, and custom will then contain the slider that lets you set a custom price range, for example, from here to here, right? And if the custom option is checked, so if there's an X here, then these cannot be checked. Only one option can be checked at the same time. Otherwise, this would not make sense. And if this is checked, then these custom options, so the first 3 we're rendering out here, will never be checked. So that's the first precondition we're checking for. And if that's the case, if we can go further, then we're gonna do one more check. And that is if the filter.price.range at the index of 0, so the first number in the tuple, is triple equal to the option.value at the index of 0. And also, right? And also same thing for the second number of the tuple. If the filter.price.range at the index of 1, so the second number, is triple equal to the option.value at the index of 1. So basically all this is saying if the current filter has exactly the range from this to this, then well, the option will be checked. So if the filter goes from 0 to 20, and the option goes from 0 to 20, then this box will be checked. So it would be this one, or it would be this one from 0 to 40. And I think this is pretty intuitive and makes sense. So we can leave it at that. That's literally all the logic, except for one thing that we want to change, and that is from the type checkbox, which actually allows multiple fields to be checked at the same time, which is definitely not what we want for the price. Only one of these options can logically ever be like at the same time. That's why we're going to change this from a checkbox to a radio, just like that, and hit save. And if we take a look at our website and what happens, we're going to see one more section pop up here. That's the price. And we can see any price under 20 euros and under 40 euros. Very, very nice. Let's see what happens when we click them and to open up the console. Let's open this up. Let's hit under 20. And we should be able to see the price is custom false. Perfect, because it's not custom. The range is 0 to 20. Perfect. Let's check if this works with 0 to 40. Let's open up the price, and it does. We can see the range of the price is from 0 to 40. Perfect. Last thing to do now for the price is to add this custom kind of option, right? And I guess that's the most advanced part of this filter, right? Because it involves 2 parts, not only the radio button, but also the slider that lets the user choose from where to where they want the prices to show. And the thing is, if we look at how this should look like, this option is nothing else than just another li element, like all of these before as well. Therefore, in code, it's just going to live still in the UL before all the closing stuff right here, just below the previous li element. So it's just another li, right? And it gets a class name of flex, a justify-center, a flex-call, and a gap of 2. And inside of this li element, we're going to put a div. It's not going to get any class name. And inside of this div, we're going to put an input component. And we could write this out ourselves, but it is going to be very similar to the previous input. So let's just grab this along with the label and kind of paste it below. Because after all, they should look the same, right? This entry right here should look the exact same as the previous ones. So it just makes sense to use the same code, the same styles for them as well. Now what we're currently building is this one right here, just for your understanding. This box is the input we just copy and pasted. Now, what should happen on change once you select the custom kind of option? What I think should happen is that the range is being set from 0 to 100 as the default. So once you click this option, the slider should always default to some value. And I think from 0 to 100, so the entire like product price range is a pretty good starting point. And as the as the ID for this, we're going to use the price, but not the option index because we're not mapping over anything, but the price underscore filters dot options dot length, because in any case, this will be the last option that is available to users. So it makes sense to use the array length to dynamically determine how long that should be. And then of course, also use it for the HTML4. And then as the label, let's choose not customer, but custom, so the user knows what's up. And the check, if this is checked, is going to be incredibly straightforward. This is just going to be the filter dot price dot is custom. So whenever we selected a custom value, then this checkbox will be checked. And because, like, to make that happen, of course, we need to change the false to a true. So whenever you click this checkbox right here, the is custom will be set to true. The range will be set to the default values, kind of 0 to 100, the entire price range. And then you can actually worry about the slider. Before we go about implementing the slider, let's see how this looks like currently. You can see the price, we can see the custom option, great. Right, what we expect to happen in the console right now, if we select that option, let's get rid of all the arrows, we're gonna fix them later, is for the price range to be custom, perfect, that works, and to be from 0 to 100, which it also is. Very, very nice. That's exactly what we expect. And that is the ideal foundation for us to now build on top of for the slider. Before we do that, let's create a div right here below the closing div under the label with a li and one ul to go. This div is going to get a class name of flex and justify between. And inside of this div, let's open this up, goes a p tag that says price, and it's going to get a class name of font-medium. Now, right below this p tag, let's create a div, and inside of this div, no class name by the way, we will put something dynamic. What is that going to be? Well, it's going to be a check if the filter.price.is custom. So if the user is currently choosing a custom value, in that case, we want to show the lower end of the price, because what we're doing right now, let's visualize this so we understand why we're doing what we're doing. Basically, above the slider, there's going to be some text. It's going to be saying price right here. Oh, and this is already small. Okay, that's fine. It's going to be the price. And then it will state like from 0 to 100 euros. Right? That's how this should look like. And the number right here that we display on the left-hand side, this one should always be the lower end of the price range. Right? And the way we determine that is pretty straightforward. For example, we can call it the min price. So let's quickly go ahead above our JSX and determine this. So the const min price, the price we can show on the left-hand side right here, the lower price from the custom range is going to be equal to the math.min, so the minimum value of any amount of numbers that we put in here, like this. For example, this would return the 1 because it's the smaller number of the two. And instead of a hard-coded 1 and 5, we're going to put in the filter.price.range at the index of 0. And also the filter.price.range at the index of 1, right? So the upper and the lower bound, and then the min price will always be the lower bound of those two. Same thing for the max price, right? Just the other way around. Instead of math.min, we can simply use math.max. And as easy as that, we now always have the upper bound that we can show on the right-hand side right here. How cool is that? So we can now go down in our JSX to the div we were just editing. And if we have a custom price, if the user is setting something custom, in that case, you want to show the min price.toFixed at 0. So this will not show anything behind the comma. And in the other case, where the price is not custom, we want to show the filter.price.range at the index of 0 and also .toFixed, there we go, to 0. So we don't show anything after the comma. And we can also use the euro symbol here, or dollar, or any other currency that you want, right? So this will be the first number right here. Let's separate this option from the next option using a JavaScript slash, so we can ensure there's always going to be space here. And essentially, we're going to do the same check again, just for the upper bound now. So the filter.price.is custom, if that's true. In that case, we're going to show the max price.toFixed of 0, and in the other case we're going to render out the filter.price.range, and you can probably guess now, whereas this was the first number, this is now the second number, so at the index of 1, .toFixed also to 0. Let's save this and already take a look at what this looks like, right? That was kind of an abstract step, so let's pause here and see what we did. There we go. That's what we did. This 0 euros to 100, and we kind of forgot the currency symbol. So let's add that in. Looks much better with 1. There we go. 0 euros to 100 euros. Very, very nice. The last thing that is missing now is the actual slider that now lets us control that custom price range, this slider. And if you're thinking like, wow, this will be a very complicated step, actually, it won't. Let's go into our terminal and I'm going to show you why. Let's clear the screen. And the reason why is because our UI library already has that fully accessible working slider, beautiful, that we can make very tiny changes to make it suit our use case. For example, adding another thumb. So we have like 2 things we can drag around on the slider to create a range. The way we install it is by using npx shared cn-ui add latest add slider. Hit enter, that's going to install the slider for us. And once that's done, you're going to see it's actually very, very easy to use in our application. Perfect, it's done. We can already start back up our development server, and then let's go down right here, and then with 1 closing div, 2 closing div, but still in the li element, let's use the slider we just created from our custom components and not from Radix, right? This slider can be self-closing. And what we're going to pass in here first off is a class name. Now this class name is going to be dynamic, right, with our cn helper function. And we want to pass a conditional class name. That's why we're using it. And that conditional class name is going to be opacity 50. And we're only going to apply this if not filter.price.isCustom. So if any other thing is checked, right, and let's restart the page, you can see what this means. If any other previous option is checked, then the slider will appear as if it's not usable because it's not. So for example, dude, this takes really long to load. I want to show you what I mean. There we go, finally. If any other option is checked, then the slider is kind of grayed out, and only if we select the custom one, then it's actually fully visible and we can interact with it, right? That's the style we want to go for. Very, very nice. And we can do that using this conditional class name on the slider. Now, of course, we actually also want to disable the slider. Right now, it just looks like it's disabled, but we actually want to disable it. So we can pass that as the disabled prop. And this is going to be same condition, not filter.price.isCustom. So if you selected any previous option, just like before, the slider will actually be disabled. Now, what should happen on value change when the person selects an option in our slider by dragging around the thing, right? Well, before, let's add the second thumb, because right now you can't do a range with this. And the fix is actually really, really easy. We can just go into our slider component and copy and paste the slider primitive.thumb. We can mark it, hold Shift, Alt, and arrow down, and kind of have 2 thumbs in here. And as you're going to see, that's going to create a slider with 2 thumbs. And why does that not? Maybe there are 2 thumbs, but we still need to set the value. Okay, so let's continue for a second, and I think that might automatically fix itself. And because that is the change we need to do here, just add 1 more thumb of the same. And then let's go down back to our slider. And we can already define the value. Let's get to the on value change in a second. Let's delay it for a bit. Let's already give this a value to see if the 2 thumbs actually work. So the value is going to be either if the filter.price.isCustom, if we want to set a custom value using the slider, then this is going to be the filter.price.range. If we don't want to use a custom value with a slider, then we're going to set it as the default custom price. And if you remember, the default custom price, if we go to that, is an array. So it's 0 and 100. So the 0 will apply to the first thumb in our slider, this one, and the value 100 will apply to the second thumb. Just as easy as that. That's why we have an array structure here. You could also do this with like 3 thumbs probably, but that doesn't make a whole lot of sense, but you get the point, right? That's what the value means, and it's always kind of a range, a tuple of 2 numbers. That's how it works. We can also pass this a minimum value. For example, the default price, the default custom price at the index of 0, which is the number 0, right? But I mean, we could hard code it, but I think it's better if we ever change it to have it all in the same place. The default value is going to be our default custom price. So the 0 to 100 range we set above. And then the max value this slider can take on is going to be the default custom price at the index of 1, which corresponds to the number 100. But if we ever change it, this will automatically change with it. And then we can also give it a step, for example, of 5, because rarely are you going to need like $1 different steps in the actual slider, but we can just set it to 5 or to 10 or to whatever you want, basically. If you're selling very high ticket products, this might be higher. If you're selling like dollar products, this might be lower, like 50 cent. Like 0.5, for example. But I think 5 works pretty well for our app. Let's comment out the on-value change for a second and see if the 2 thumbs actually show up, because they should. So let's restart the page. And yes, there they are. There are our 2 thumbs. And if we choose the custom range, then we can see that our slider becomes visible, that we can interact with it, but we can't drag around the thumbs yet. And the reason is because we hard-coded the value, but didn't give it an on-value change. So it will always be the 1 to 100, and we literally cannot change it as is. That is why the on-value change, we receive something called the range, which corresponds to how many sliders or thumbs we have in the slider. So in our case, this is going to be 2. So in our case, we can right away destructure those, the new minimum and the new max, right, from the range. We can use array destructuring syntax to get access to those 2. So whenever the user changes the thumbs and slides them around, we're going to have access to the new values just like this, and can set them to our filter state. So we can say set filter to anything it was previously. We can simply get access to that. Once again, you probably know the drill by now, by spreading in all the previous options and only changing the price. And now, of course, the value we're going to set here is for the is custom true, because it's literally the custom slider, right? It just makes sense to set it to true here. And then for the range, we're going to say from the new minimum to the new maximum, just like this. Now, if you're wondering why don't we use the range right here directly, well, that's because TypeScript will complain. TypeScript thing. Once again, yes, this would be perfectly valid syntax. This would work, but you would have to use something like @ts ignore. And I really try to avoid this, and not even this works. Maybe we should set it here. Yeah, this would work, but I don't like to use ts ignore. And I think this is just a much nicer way of going about things. Same code, but no TypeScript suppression, So I think this is just a better way, while still achieving same functionality, as I said, right? And if we save that, then we should notice that we can now actually slide around the price. So let's try it out. Let's go for custom. And yes, this works. Very, very nice. And even if we try to drag the second thumb before the first one, we always have the lower bounds on the left and the upper bounds on the right-hand side, so no user can mess this up. Very, very nice. Okay, so let's actually change the product results based on our filter. I mean, dude, we're literally keeping track of everything so nicely. How about we finally send that to our API and then do some performance improvements and better error handling. So right now we can see the price range would be 10 to 80. Perfect. If we set this down, then the price range will be 0 to 80, just as we set it, or like this, then it should be 0 to 40. Let's verify that. Very, very nice. And also the is custom property is now false. Perfect. Okay, so we keep track of all the filters. One thing you're gonna notice is while we drag this around, there's a lot of state updates. This is something we're going to fix, by the way, by debouncing the state. We're gonna get to that. First, let's make our product's results actually change by sending along the filters with our API request up here. So we're already sending the sort filter. Perfect. So what do we need to add? We still need to add the color, which is going to be the filter.color. We need to add the price, which is going to be the filter.price. And lastly, we need to add the size, which is going to be the filter.size. And that's all we need. That's what we're going to send along to our API request, where we now have all the data we need in our route.ts that we already created under API/products to kind of process that request and get access to the data. So how do we get access to the data in the first place? Well, we can say the const body, the request body in this post request, will be the await rec. And the rec is just the request that we get access to right here, which is going to be of type next request, by the way. And we can simply call the await rec.json. This is an asynchronous operation that's going to convert the request body that is sent along into a JSON format, assuming the content type is application JSON, which in our case it is. Now comes a really cool step. You remember that product validator that we wrote to kind of base or type on in the front end. The cool thing is we can use the same validator to validate the incoming data in our backend as well. The way we do that is by using the product filter validator right here in our backend, .parse method on it, and in here we can simply pass the body.filter. So what we just defined on the front end that we send along right here as an object, we now parse using our schema validation library in the backend to make sure that the request only contains the data and exactly the type of data that we expect. Super, super cool for security. And also for type safety, because this literally gives us full type safety of what we receive, because if the incoming data doesn't match our schema, then the request will be rejected automatically. Perfect. So we can destructure the color, the price, the size, and the sort in our backend. Full type safety, right? How cool is that? And we can now actually apply the filter in our backend. Now, the way in which you construct the filter mechanism is going to be a bit different for each database that you're using. The database that we're using in this video expects a format like this, where we have the color is equal to, for example, white, or, right, it goes into the same string, or the color is equal to beige, for example, and then we can join that together with other conditions, like where the size is equal to L, for example. So in this syntax right here, we would only allow beige and white products like this, and products that are in the size of L, for example. So again, the syntax kind of differs. This is the syntax that we need for our application. I'm going to show you a very, very neat way of implementing just this. And we do this using our own class, and let's call it filter. If you've never worked with a class in Java or TypeScript, don't worry, this is going to be a very, very simple implementation. But I really like this API design that I want to show you. So the only value that we're going to keep track of in this class is going to be a private value. That's going to be the filters. The reason we're making this private is because we don't want to access that later where we use this filter. And this is just an internal value for the class, so we can mark it as private. This is going to be a map, and this map we can pass a generic for TypeScript is going to contain a string that maps to a string array, which are the conditions. So this could be, for example, color, and this could be white, beige, and purple as the string array in here. And we're going to default this to a new map, just like this. Very, very nice. Now, we are only going to have 4 different methods on this class. First one is going to be has filters, which is just going to check, do we have any kind of filter at all? So the logic is very, very simple. We're going to return this .filters.size is larger than 0. So do we have any kind of filter applied? That's going to be a check we're going to need later. Second function is going to be add. How do we add a filter? This is going to take a key, which is going to be a string. An operator, so for example, is equal to, larger than, smaller than, that's the operator, also of type string. And lastly, a value, which is going to be either a string, so for example, L or M or S, or the color, like white or beige, or this is going to be a number, like the price, for example, like 100, in our case, euros or dollars or whatever you want, right? So inside of this add function, let's get to the actual logic. And if we add a filter, all we're doing is pushing into the string array in our map, right? That's literally all this is. So we can say the current filter, or just filter, we're going to call it, but it is the current filter that is applied, is equal to this .filters.get the key. So for example, if we already have a color filter applied with white and beige, and we now want to add purple, then filter is going to contain the previous values. Now, if the filter doesn't exist, let's also put this OR as an empty array, so we can push into an empty array instead to avoid the weird edge cases. And then we can say filter.push, and we can push a string into here. So this is going to be a template string. And first we're going to put the key, so for example, the size, then the operator, for example, equal to. So for example, let's comment this in. This part we're writing right here could be, for example, the color, right, as the key, then the operator is equal to, and lastly will be a check, right? If the type of value is triple equal to number, in that case, we're gonna put the value directly, and else we're gonna put another template string in here where we wrap the value in quotation marks, and then the value goes in here. So basically all this is if the value is a string, then we're gonna wrap this in quotation marks, like where color equals to white. But if this right here is a number, like the price, right? If the operator is price is equal to 120, then we don't want to wrap it in quotation marks. That's why we do this check right here. In that case, we want to list the number directly without the quotation marks around it, right? That's what the check is for. And then lastly, we're gonna say this dot filters dot set the key to the filter we just created right up here. So we're kind of adding on to whatever we had in the map previously by the item that we just added. And that's all the logic there is. We can also define a function that is the add raw. In any case where you want to do some custom stuff, have more flexibility than just the add function allows, you can add a raw filter if you want that consists of a key that is a string and a raw filter that is also going to be a string. We're also going to make use of this so you can see what the implementation looks like. And the logic is very simple. We're just going to set the this.filters and then .set where the key is to the raw filter, but inside of an array. So it's going to be the only element in the array, but of course we are expecting an array of strings, so we couldn't just pass the raw filter because this is just a string and we expect an array to be in our map. Perfect. Last thing we're going to add on the filter class, we're almost done by the way, is going to be the get function. Because right now we are going to have a bunch of properties like color. This maps to, for example, white and also to beige. And imagine we also have the size in our map, which maps to like L or also to S, for example, right? This would be our map up here. Now we construct the actual search string, because do you remember what I told you, which format we expect here? It's something like color is equal to white and also the size is equal to L, for example. So we need to convert this map into this kind of syntax, and that's what we do in the get function right here. To do this, let's first define an empty array and let's call it parts. So the const parts are going to be a string array and we're going to default them to an empty array so we can now push into them. By the way, why do we still have the console open here? We don't even need that. Anyways, let's now go through each filter and join each thing together using OR. So for example, if we had multiple colors, then it should look like this, right? Where we join them together with the OR operator, because any single color of these is totally fine. So we're going to go through each filter. So this .filters .for each filter, we are going to run the following function. So first off, we're going to say const grouped values is going to be equal to filter.join, and we're going to join them together with the OR operator separated by spaces. So basically we're taking each value that is in the certain filter that we're going through and joining them together with OR. So we transform them into this kind of syntax right here. And then the overarching ones are going to be joined together with AND. So we apply them as well. So how do we do that? Well, first off, we need to push this into the parts. So let's say parts.push. And what are we going to push? Well, inside of a template string in parentheses, just like this, we want to push in these group values, which is essentially like this first part, right? So only the colors, but all of the colors together, we're going to push into them in parentheses, right? These you can see right here. That's what we're doing. And let's put the grouped values right in here and push them into the parts. And then all of the individual parts like this and this are going to be joined together with the AND operator. So we can simply say return parts.join and join them using the AND operator. That's what I meant to say. Beautiful. And that's literally the entire filter logic done. What we can do now, API design-wise, looks very, very nice in my opinion. So we can say the const filter in our actual HTTP handler is going to be a new filter and instantiate that. Now look at this. We can say color.for each color that is passed into this API route. We can simply call the filter.add and now pass three things. The color, which is the category that we're going through, then the operator, which is going to be AND And lastly, the value, which is going to be the color we get from our front end, like white, beige, green, purple, and so on. So we set this filter and they will automatically be joined together like this in the filter class. We don't even have to worry about it. How cool is that? Same thing, Shift Alt arrow down for the size. So size dot for each. And by the way, if you wondered how I mark two things here at the same time, mark the first one and then hit Control D, and that's gonna mark multiple of them. And we can also mark the next two, so hit Control D 2 more times and just change them all to size. As easy as that, right? That's why I really like this filter implementation. And lastly, for the price, we can call the filter.addRaw function that we defined above. So this is going to be the price filter. And as for the value that we're going to add here, this is going to be a template string where the first price is larger or equal than in dynamic the price at the index of 0. So the lower bound that is passed to this API request. And also where the price is smaller or less than equal the price at the index of 1. So the upper bound of the price range, right? So realistically, this would be like price larger than 0 and price smaller than 100. That's how we enforce or filter in the database level. And if you're now curious what we're doing with the has filter, which we haven't used yet, that's what comes in clutch right now. Because in our database request, we can add a filter. And this filter is going to be, if we have a filter.hasFilters, in that case, we want to pass the filters here. So filter.get, right? But if we don't have any filters, then we also don't want to apply any. So we're just going to pass undefined in that case. So if we have filters, we're going to use them. If we don't have filters, we're not going to use any, because of course we can't, but we also don't want to pass an empty string here. So that's just how we tell our database that don't apply any filters in that case. Perfect. And that's literally almost it. The last filter we haven't used yet is the sort filter. So either none, price ascending, or price descending. And the way we do this is actually really cool, and it lies in the nature of a vector database, which by default queries the most related vectors. And if you remember what a vector means, a product vector, when we set that, for example, in our seeding script right here, the vector corresponds to the product color, the product size, and the product price as the third number in the vector. So that means when we set the third number in the vector to something like 100, right, and save that, you're gonna see, if we refresh the page, then it's going to list the most expensive products at the very top, because those are the most related to this vector right here that has 100. And why does this take so long to load? Oh, and it looks like we get an error. So what's the problem? Let's take a look. Expected array received object invalid type. Where did that happen? So we passed something invalid. Path price expected array received object. So it seems like, what did we do? What did we pass to this? Let's debug this together, because I think the problem lies right here, the price, because chances are, yes, this is the problem. We need to pass the price.range right here. So right now we pass the entire object of is custom and range, but all that matters to the API, right, is just the range from 0 to 100. The API doesn't care about the is custom value. Or component does, of course, to handle the logic, but our API doesn't. So we just need to pass the range right here and transmit that to our API route. And that should work. Let's restart the page, and hopefully everything should go smoothly. Very, very nice. It did. You can see the page successfully compiled now. And we have the most expensive product first, which is because we changed this vector to 100, so the highest product price. If we change this back to 0, it would be the exact opposite. Well, the cheapest products would be listed first. So that's how we do the sorting in a vector database. How cool is that, right? So we can basically change this number, and that's going to determine the order in which we sort. If you use any other database like Postgres or MySQL, you would of course use the order by in that case, right? In a vector database, it just works a bit different. So what we can do is do a check. If the sort is none, right, then we're going to use the average product underscore price as the, like default to search by. And this is a magic number. So again, a constant that we always declare in all uppercase and declare above where we use it, or in a central file if you prefer that. So for example, the const AVG product price is going to be equal to 25. That's like about the average of our products in the store. Of course, in a real world scenario, you could actually get the average from your database, calculate that by aggregation and whatever, but this is totally cool for our use case right here. So 25 is just the about average product price. And else, if we have a sort, if something is passed, so if the user has either selected the sort by ascending or descending up here, right, low to high or high to low, then first off, we need to check which one did they check. So if the sort is triple equal to price ascending, in that case, we are going to default the price to 0. So to list the products from cheapest to most expensive. And in the other case, we're going to use the max product and price also as a constant that we declare right below the average product price. So for example, we could say const max product price is going to be equal to something like 50. In our case, I think that is the maximum at $49.99. So using 50 works pretty well. Let's format this so it looks much nicer. There we go. That is our sorting logic. Let's play around with it. Let's see if that already works. Let's refresh the page and let's sort low to high, for example. Let's hit that, and it seems like, oh yes, we forgot one thing, one small thing, so it doesn't work yet, and we're gonna fix that in a second. Right before that, we're almost done in this API route, I promise. One really good idea is taking this entire HTTP handler and hitting Ctrl-X to cut it, and then wrapping it all inside of a try-catch block, where we catch the error and then can handle it. So this is much better error handling, and pasting that back in the try block. And for example, the error handling could involve, i.e. logging the error to Sentry, right? Log error to Sentry, which we use, which I've used a lot of at work. So this is a tool you're gonna see a lot in real life in enterprises to kind of see how errors happen, why they happen. In our case, we can just say console.error and log out the error. So in the runtime logs, we will see this error appear. And we're also going to return a new response from this API route where we say json.stringify. And for example, in the message we send back, we can say something along the lines of, message internal server error. Of course, you should do like certain checks on the error, if like error instance of error, then whatever. But this in our case is totally fine right here. And then as the status for this, we can send back status 500 to indicate the internal server error. Okay, little cut there, because for me it is the next day, but we are gonna continue right where we left off after improving the error handling right here in our route.ts. Okay, so one thing you might notice, right, is currently in our app, if we change the filters, then we keep track of the actual values in state, but the products don't update. So if we go to our console, we can see the state is correct. For example, the colors. Right, we're only allowing blue, green, and purple right now because white and beige are unticked. It's a bit small, but you might be able to see it. But the products are still like white and beige, right? So the products don't actually change. How do we change that? Well, how do we make it right? And the answer is that's going to happen right here in our page.tsx. Because while we are making the changes to the state, for example, through applying the array filter, we are never actually refetching the data. And that could not be easier with React Query as well, because, for example, what we can do is simply get the refetch function from React Query by destructuring it from our use query right here. And what that does for us, right, is now we can define an onSubmit function. Let's say const onSubmit, and this is just going to be equal to an arrow function that simply calls the refetch method. Now, the reason we're defining this as a separate function instead of just calling the refetch itself is because if we ever want to change the submission logic, then it's going to be much more straightforward in this approach than calling the refetch directly across our entire component. It's just a bit nicer, a bit more readable, but it doesn't make like an insane difference. And this onSubmit we can now actually use wherever we change the state, right? To actually go ahead and refetch the data. For example, that's going to be at the very bottom of our apply array filter function. And now, if we save that and head back over to our application right here, read out the page, and change any array value, for example, exclude the white right here, then we should be able to see that the colors are excluded. But there is a small problem here, it seems. interesting. So right now, when you untick the white, nothing happens. But when you untick the beige, then the white gets removed. I think this is a pretty easy fix. But let's take a look at the network tab, because I'm just interested in what happens here. Let's go to the color. Let's untick this. Interesting. So the request is made to our backend. What does it contain? It contains the, let's see, as the payload, sort none, color beige, blue, green, purple, white. So interesting. So the state is still included in our request. So the old state that we really don't want to have in there is still included. Okay, interesting. I'm going to take a second to see why this is happening. And of course, it makes sense that this happens because of the logic right here. So that's one of the main kind of hurdles you have to get through when understanding React state. I bet most of you already know this, right? So I'm not gonna go too much into detail, but essentially state updates are not synchronous. So once these run, once this if statement is done, right, the onSubmit will already make the request to our network, but the state doesn't update yet. Like it hasn't updated yet. It will a few milliseconds probably after this call, but because we fire the call and then the state updates, the state will not be included in our request to the backend. And now there are multiple solutions to this, right? The easiest one, I guess, would be, and you don't need to follow along right now, I'm just demonstrating this. The easiest way to go around this would be in something like a use effect, where every time the state changes, so the filter state updates in here, we then fire or onSubmit call, right? This would work. Let's save this and let's see what happens if I was right in my theory that this is the problem. Let's go ahead, give this a bit more space and untick the white. There we go. That fixed the problem. Okay, interesting. So I don't like this approach. I think there's a better way, because what we are going to do anyways, what I teased in the very beginning of the video, do you remember when we talked about this price slider right here, right? Where every time we change this, we don't want to make a request to our network, but we want to debounce this input, which is really nice for performance. So if you change this all the time and then stop for an interval like 400 milliseconds, for example, only then will the request to our backend actually be made. That's called debouncing. It's a really, really useful technique in a lot of scenarios, and that will also fix the problem that we have right here. Now, how do we debounce this? And actually, this is extremely easy. Let's say pnpm install lodash.debounce. Now, this is a utility package that helps us achieve this. You can definitely do this yourself as well. The code will just be a bit longer without this package, right? It's just a small utility we can use, makes debouncing super easy, but honestly, debouncing yourself is not rocket science in any way either. Anyways, we're gonna use this small little helper here, and we're gonna say at the very top of the file, we can simply import the debounce from lodash.debounce, the package we have just installed. And by the way, because this is not a native TypeScript package, we also want to say pnpm install -d as a development dependency, the add types /lodash.debounce. So that's going to be the TypeScript types that are going to help us use this and actually resolve this error, so TypeScript knows what the hell is going on here. And that's all we need to do to get started in debouncing. And the actual logic to handle debouncing is pretty straightforward. So what we're going to do is declare two things right here. The first one is going to be the const debounced submit. So basically, you can call the debounce submit later as much as you want, but the function is only going to get called after that interval that we set. And this is going to be equal to debounce, the one from lodash.debounce. And now the function that we want to debounce, it's the onSubmit function right up here, this one. And then the interval. So for example, if you completely spam this function by changing the slider around like this, we're completely spam invoking the function. Only then after a break of 400 milliseconds of not moving the slider, only then will the function fire once. That's exactly what we're saying right here. And to make this work in React, I want to show you why I'm just going to show this to you. Why can't we use this as is? Because there's a problem with this implementation that's easy to fix, but I want to show you what happens. So let's go down to the slider, right, where we change the sliding logic right here in the on value change. And whenever we change the slider, we are going to invoke the debounce submit. And let's see the problem in this implementation. So let's open the network tab, and we're going to see if we change around the slider. Oh, and we of course need to restart our development server. Let's go into full screen here and let's let this reload, because what you're gonna see is that the debouncing, it kind of works, but not as you expect. There's a very fundamental problem in this implementation. So let's let this load, and this takes, once again, super long the first time you load your page in Next.js. There we go. Okay, so check this out. We're gonna go to the custom price and pay attention to the network tab right here. Okay, so I'm gonna drag this around, bam, and you can see, well, we still fire a request for every time the slider is changed, but it's just delayed by 400 milliseconds. And that's exactly not what we want. We only want to fire one request. This still completely cooks our API. It spams the backend to hell, right? Why is that happening? Well, because the reference of the function is generated new each time that this component renders. Essentially, this is now a new function when the component re-renders. It has to do with how React works under the hood. And basically the function integrity changes and React doesn't know that, hey, no, you shouldn't run this function again, right? And to get around this problem, it's actually really easy. Let's say const underscore debounced submit. And this is simply going to be equal to use callback. And we're gonna wrap the debounced submit in this on callback. And then the second argument we're gonna pass in here is an empty array. This is the dependency array that we're gonna leave empty. So only when this component first renders, the function integrity is going to be created, or the reference to the function rather. I think that makes more sense. And then it never changes, essentially completely circumventing the problem we have just faced with the debounce that is created new every time this component re-renders. That's exactly not what we want, right? So this underscore debounce submit, we can now completely spam as much as we want, and only after 400 milliseconds pause will the function actually be called once. And this is the function we're going to use, for example, in our apply array filter right here. So whenever you change the color, then the new products are going to be fetched. Let's already see this working, right? Let's restart our application. Let's now remove the white color, and bam, the white color is gone. Bam, the beige color is gone. Bam, bam, the colors are gone. Very, very nice. We know this works now. That means we can now use it in all the places where we need to. For example, that's gonna be right here in the sort options. If you change the sort options, then we want to refresh our data. So basically we can now call this everywhere where when the user changes something, we want to refresh the data on the page. That's also going to be not here because that's already happening in the apply array filter. So we don't need to implement it there. Same thing for the size filters, it's already being handled for us here. Perfect, we don't need to worry about it, but we do need to change it, for example, for the price filters. So let's also refresh the data once you select the custom option. And also, of course, this is going to be, oh, never mind, that the previous one wasn't for the custom option. So the previous one, the debounce submit we put up here into the inputs, this was for the any price, the under 20 euros and under 40 euros. So when you click one of these, the product should be refreshed. Exactly. And then right down here, this is for the custom option once you select it. And this one in the actual slider is then for once you actually change the thumbs on the slider and drag them around. All right, let's save this and see if it works. Let's go into kind of full screen here, restart the page and see. So can we remove colors? Yes, we can. That works. And we are batching the request together using the debouncing. How nice is that, man? Very, very cool. Same thing for the size. For example, this is size S. Let's filter those out. Bam, they're gone. Size M and size L, no size S anymore. Very, very nice. And now for the price, under 20 euros. Does that work? Yes, it does. Under 40 euros. Yes, that works as well. Now the products are more expensive. And for example, we could select a custom range from 0 to let's do 25. So all the products are filtered out as we drag around the slider. Very, very nice. We are almost done. The very last thing you'll notice is, for example, if we only allow products from 0 to 5 euros, well, there are no products matching that criteria. However, the UI doesn't show anything. This doesn't look good. We want some kind of empty state to handle the case where, for example, all the filters are unchecked. There is no product matching the required search criteria, right? And adding that is surprisingly easy. To do this, we're going to create a new file in our components and then products where everything related to a product lives, and create a new file called empty state.tsx. And this component is going to be really, really simple. let's say const empty state, state, and this is going to be once again, of course, an arrow function that we export default at the bottom, the empty state. There we go. Okay, from here, we're going to return a div at the top level with a class name of relative, a call dash span dash full. So even if we put it inside of a grid, the entire thing is going to, it's going to take up the entire space, basically. Right afterwards, a height of 80, a background gray of 50. We're going to say width of full, a padding of 12, a flex dash call, an items dash center, and lastly a justify dash center as well. Now, inside of this div, we're going to put an X circle, which is an icon we get from Lucid React. And let's give this a class name of height 8, a width of 8, and a text red of 500 to indicate that something went wrong, you know? Now, right below this, let's put an H3 element with a class name of font dash semi-bold, and also a text of XL. And inside of here, we're going to say no products found. Perfect. And right below this, let's create a p tag. That's the last element of this component. This is going to get a class name of text zinc 500, and lastly of text-sm for small. And inside of this paragraph, we're going to say we found no search results for these filters, period. That's not a period. That's a period. Very, very nice. Let's format this file, save this file. And the last thing we need to do is now actually use the empty state wherever we need to on the page. And that's going to be right down here where we render out the products. Because one check we can do right here, right, is if we have the products, if the data came back from the backend, but it's empty, then we know there are no products matching the criteria and we need to show the empty state. So the logical check, we can slightly modify it to products and the products.length is triple equal to 0. So we have the data, but there are no products in the data. In that case, we are going to render out the empty state we just created like this. And then just like before, else, so colon, if we have products, then we are going to map over the products. And else we don't have products and we don't need to show the empty state. In that case, we are going to show the loading state. So by slightly modifying this ternary operator right here with one more logical check, we can save that. And then once we make a selection that has no product inside of it, like for example, a price from 0 to 5, then it's actually going to show our empty state because no product matches the description. No product is between 0 and 5 euros. Very, very nice. And now I just noticed a bug that I didn't notice in the earlier version of the project. And so we are going to fix it right now live together. So what is the bug? Basically, I just noticed when we unselect every color right here, I think this worked in the demo project, but it doesn't work in this project right here because what's happening is if there is no color selected as the filter, right? Basically, we're sending over an empty array to our backend, not adding any filters because the for each doesn't get triggered from an empty array. And basically we don't have any color filter applied, not even that the color should be empty as we state right here with the filters, right? So it's just going to search for any color in that case. So basically what we need to do to fix this, let's do this live together, is do a little check. If the color.length is larger than 0 and we are in our route.ts, by the way, in our backend, in that case, we're going to go through each color and add the filter. And we're going to say else if the color.length is triple equal to 0. So if an empty array is passed, then we can say filter.addRaw, and we're going to add this for the color key. And as for the filter that we're going to add, that's going to be color is equal to just an empty string. So empty quotation marks, no color is going to match that. Therefore, we should be able to see, hopefully, that this works now. Again, I'm just winging this together with you, but let's see if that works. Let's exclude all the products, and very, very nice, it does. Perfect. So again, I didn't prepare for this, but I just noticed that. So let's just fix it while we are here. Very, very nice. And then we can do the same thing for the size. So if the size.length is larger than 0, we are going to apply all the filters for it. And then else if the size.length is triple equal to 0, in that case, we're going to say filter.addRaw. And this time we want to add the filter for the size. And then the filter we're going to add is size is equal to an empty quotation mark just like this, and we can leave the price as it is. That works. Perfect. Let's save this and do a final check if everything works. Let's read out the page and let's exclude white, and let's exclude green, and let's exclude purple. We don't want those colors in here. And you know what, just for demonstration, let's only have beige products in here as well. Okay, so size, let's filter out the small ones and let's filter out the large ones. So we only have medium products. Yes, that works, very nice. And now if we select a price under 20, we should be able to see no products. Let's try this. No products found, perfect. Under 40, we should be able to see 2 because there are 2 shirts under 40. And then if we do any price, we should be able to see the more expensive one as well. Perfect, let's go for a custom price. Let's choose this, everything should be shown. Let's choose until 40, only 2 should be shown. And if we go this low, then no products should be shown. Perfect. Dude, that is so cool. Let's reselect all the filters. That's going to show any product. Let's go for any price as well, collapse the filters, and I'm really happy with how this turned out. If we now sort low to high, we can see the cheapest products first. As we scroll down, it gets more expensive. And if we select it the other way around, then we're going to see the most expensive products first, and then it's going to go descending to the cheaper products. Super nice. Okay, so we made sure everything works. Very, very nice work. That's the project, and I really hope you learned a lot. So great job following along. I'm really happy with how this turned out, and I hope you are too. And congratulations, man, on finishing the project. Hey man, very, very nice job following along. And I mean that. Like, making these videos is hard. Like, it was 4 hours of raw content, I believe, that I cut down then. And you followed along with the whole thing. Like, massive respect, man. It's like 2.5 hours now, maybe a bit more. That's not easy. And I really hope that you agree. I kept my promise to go through everything step by step together and provide you with all the resources, everything for completely free. And I really hope you enjoyed this video, like watching this video, as much as I enjoyed making it. So big respect for following along. I really hope you learned a lot that you're going to be able to use in your future projects. Congrats on finishing the project. Very, very nice work. And that's it for me for this video. Again, I really hope you enjoyed. I'm going to see you in the next video. Until then, have a good one and bye-bye.